Welcome, everyone. This is Michael Gibbs. How are you all today? If you're awake and alert and oriented and ready to get started and learn some networking, type networking in the chat box. So we know you're here. Everyone, this is Michael Gibbs. How are you all today? Bear with me. I got some noise in the background. I'm trying to monitor what's going on so I can see when people are calling and asking questions. So bear with me for having my speaker. Anyway, type networking or cloud networking if you're ready to go. Today we are going to have a fun time, everyone, and welcome. And networking is near and dear to my heart. From that time back in 1998, where I bought a house full of routers and servers and started building networking, to my 25-year architecture career, networking has always been at the center of it. If you don't have a network, you have nothing. And you know, here's the funny thing about networking. In all these decades I've been involved, almost no one thinks about the network until it doesn't work. And then when it doesn't work, we go straight to the network. So what is a cloud? It's a virtual network and a virtual data center. So you want to be great at the cloud, you've got to get you great at the network. We also got to get you great at the data center. And to that end, we're going to be producing a tremendous amount of networking training for you. Networking is the core of anything we do. Now, in order to do this, we're going to bring you some experts from around the world. On the networking front, you're going to see a lot more of Imran and I. I want to let you know the kind of background that Imran and I have so you can understand where we're coming from. Both Imran and I are both Cisco certified internet experts for a very long time. When we add up our time and experience, it's over 50 years worth. Now, Imran and I come from a slightly different part of the same career. We both started as network engineers. I enjoyed my network engineering career more than you can possibly imagine, and then moved into architecture. And I loved architecture. And as an architect, I was doing more of the business work, doing more of the systems design. And you know who made sure our architectures worked? It was the network consulting engineers at Cisco. People like Imran were the people behind people like me, making sure that everything we designed worked. They would test it. They would proof of concept. They would show it to the customers. I would go to someone like Imran and I would say, Imran, look at my design. I worked on it. Can you find any gotchas? And Imran would look at it and some would say something like, yeah, over here, this will work, but it would be better if you tune it this way. And that's part of the architecture process. So I am beyond excited to have Imran with me. Imran, I'll have him tell you a little bit about himself, but he is a real network engineering expert and a cloud expert. And because of this, you're going to hear a lot more from Imran and I coming soon. We're going to have a series of video networking training. Today is going to be fundamentals. And when we say fundamentals, understand that our fundamentals are far more than an AWS advanced networking. Today, we're going to build a network. Now, previously speaking, we designed a network. If you go to the previous week, Imran and I, and we did the plan, we talked about what the IP addressing would look like. We talked about what the routing protocols would look like. Now today, we're going to actually build it. So when we build this, we're going to do the configuration of the Cisco routers. Imran's going to introduce you to the simulators that we use. You're going to hear how and why things work. And then we're going to build them. And then when we build them, we're going to show you routing tables. And then we're going to trace packets through the network. And then we're going to show you how we engineer traffic from point A to point B. We'll build a high performance, high availability network. Then we're going to connect this network to the internet, or at least the pseudo internet. And we're going to see how routes are going to be coming in. And after we do that, then guess what? We're going to connect it to the internet service providers and see this. Then we're going to connect it to the cloud with two direct connections. And heck, you know what? We may even make an IPsec tunnel to show you what a VPN is, but it's going to be a fun time. So Imran, you want to kick it off for 2 minutes and tell people about some of the amazing tech things that you use on at Cisco and Juniper, as well as the last 25 years before we begin?
Yeah, thank you. Thank you, Mike, for a nice intro. I've been in the industry, as Mike described, for almost 20 years. Been architecting, designing, implementing a very large mega-size project in Cisco, Juniper. I'm a route switch, a data center CCIE. I'm here to produce some content for you guys, have some POC and testing, how the routing, the BGP works, especially in the cloud area. So So I'm here to help, and we'll have some demo. What to expect on this demo. We laid out some topology for you guys, and we step by step we configure the routing protocol. We describe what tool we are going to use, and step-by-step approach from EBGP, IBGP, how the route works, how do you simulate the cloud in a different aspect, what are the key concepts are, what you really need to understand, and how easy for you to simulate any kind of network, either in your test lab, in a production lab, and the tool we use is very handy and classy. Mike.
Imran, thank you so much. Great overview. So we're going to be playing with a few technologies today. So I'll introduce them before we get to work. The first thing we're going to be playing with are routers. And routers are network devices that connect things from a layer 3 perspective. They move your data through the network. The way they move your data through the network is as follows. They have something called the routing protocol, and we're going to configure some routing protocols today. A routing protocol is basically something that builds a map of your network. If you need to go from point A to point B on your GPS, make a left here, go straight, make a right, that's your route. Guess what? Routers do the same things. So internally, inside of our organizations, we use something called an interior gateway protocol. And we're going to configure an interior gateway protocol today. An interior gateway protocol is something you use inside of your network to recalculate your routes, and it does it fast and efficiently. And if you've got a cable cut, it routes around it very fastly. And we're going to configure an IGP or an interior gateway protocol, and it's going to be OSPF, or Open Shortest Forest Path, a link state routing protocol, which is one of the most common ones used in the enterprise environment. As a cloud architect, you need to know this. And then we're going to configure an exterior gateway protocol, which is going to be BGP. And we're going to use this to connect to the internet service providers. And of course, we're going to use this to collect to the cloud or to clouds, which we probably will do. Then we'll manipulate our traffic. We'll do some filtering. So it's going to be really fun. So what we're going to do and how we're going to use this is we're going to use a simulation software. Now, when we train network architects and network engineers, we love using this simulation software. It's called EBENG. And of course, Imran will talk about that in a minute. But what it's going to enable us to do is build in real time networks, test configuration. EBENG is used by a lot of organizations in the proof of concept stages. They can make it up, they have a plan, they can build in this environment, and then they can test it. And then that's part of a proof of concept and a simulated environment, which is extraordinarily good. Also, people use this to pass their CCIE exams and their CCDE exams. And of course, you're dealing with 2 network architects and engineers with 50 years experience and 3 CCIEs. You might see some network training coming from us, really big heavy duty training, like how to become a network architect from scratch. So lots of fun coming in there, but we're going to use EBENG. So Imran, you want to talk a little bit about EBENG, where you have it set up before we begin?
Yeah. You want to let me share some topology, Mike, and then I describe what's the. Are you seeing my screen, Mike?
Absolutely.
Okay. So basically, guys and Mike, this is like one simple topology we made for you. The tool I'm using, as Mike described, EBNG, and in EBNG, just describe a few things, or you can simulate. You can simulate basically anything, and you can do a certificate testing and have all kind of product is available. These are the routers we are having, the Cisco routers, and you can see if I click on the thing, I'm on the device right now. So it's heavily used in the industry for testing, and organization use it heavily in different simulation. They are basically is a topology, and you can drag and drop any kind of nodes here, and you can have any kind of networks here on the cloud. One second. Guys, sorry, Mike.
That's all right. I almost worked for Aruba many years ago. But then Cisco gave me an offer at the same time, so I turned down Aruba. Well, they were, it's some really great wireless technologies. I could not go to Cisco. And of course, you've got this running where on a server. Is it running on bare metal or are you running it in a virtual machine?
I'm running in a bare metal server, and I'm running this this EVNG as a VM on site to that, and as a like a VM running on a virtual machine. But I'm running ESXi on top of it and running a VM for that. So there was a lot of. Let me share the screen, like the features. You can have a topology design. You can import, export configuration. You can have a picture imports, click and play. You can have like custom level L2 protocols, CPU watchdogs, multi-users, different kind of features. You can have it, and basically you really simulate the network fully supported, and you can run simultaneous labs basically, and it is drive from Ubuntu 16.0 server from the long-term support, and it supports UNet labs, and you basically ability to learn and transpond the real network very quick. And you can, as Mike said, you can we used to, I'm still using it for my CCIE lab scenarios and customer simulations and any kind of network you can simulate. So that's a absolutely awesome tool. Other advantages, you can have multiple users, you can have control permissions, you can have a create tasks, lab task scenarios, and there is a two kind of versions available. I'm using a community. I'm using a pro version. The community version is free of cost. You can share the design labs with friends and others, and import, export config, and much more. And of course, if you go for a pro version, which is like $100, you have other features are available, extensive features are available, and you can have 1024 nodes available per lab. So extremely useful, extremely robust, and very easy, user-friendly.
So let me clarify, Imran, what you mean by nodes. He's saying you can literally have 1,000 different routers operating all at the same time. So that's how big you can actually test these things. I want to point out one thing that Imran said, because I think it could be really helpful to you when you guys build your test labs. Obviously, if you're our students in our Cloud Architecture Real Development Program, you have access to our servers. But if you're not with us, you know how we always say, get yourself a 16-core Xeon server with a minimum of 128 gigs of RAM and either an NVMe drive or 3 SSDs and RAID 0. What Imran said is he's running VMware ESXi. So he's installed VMware ESXi on the server. He's got this really great lab simulation running on the server. And guess what? He could still in another VM set up Microsoft Active Directory. And in another VM, he can actually build an OpenStack Ansible cloud. So he can do all this on a single machine through the use of virtualization. So I just wanted to point that out. I'll go back to you, Imran.
Yeah, so if you see the topology, I'm running, these are all Cisco devices. I'm simulating here is like two routers where they are running between EBGP and this like exterior gateway protocol. I will talk about it. What is it? And you can simulate this as any of the cloud here, like maybe AWS cloud. You have EBGP connection. And the other thing, you can have EBGP with another GCP cloud. And other thing is I'm simulating on the left hand. On the middle, we are all running IBGP, and I'll explain what IBGP is between IBGP and EBGP. And on the left-hand side, I'm running a dual link for another service provider, maybe your internet or maybe another company you acquired, and how to run, have a multiple links. So the internet, you have multiple links, or any other company as a provider.
Yeah, so that's the perfect topology, Imran. Today, we're going to pretend as follows. This little blue thing in the center where it says Autonomous System 200, that's our customer data center for what we're working with today. Now, The two links that Imran drew to Autonomous System 100, AS100, we're going to view that as the cloud provider. And we're going to have a primary direct connection to the cloud provider via Ethernet 0/0. And guess what? We're going to have our backup direct connection via Ethernet 0/1. So that's going to be your high performance, high availability routing to the cloud. Of course, as Imran said, up top, AS500, we're going to connect to the internet. We're going to use BGP. He'll explain all the reasons why we're using IBGP and the way that it's set up and the time occurs. And of course, we're going to connect to another cloud, call it Azure on the right side, AS600. So multiple direct connections to multiple cloud providers and internet service providers, high performance routing. This is a real network, everyone. So I want you to understand what it is we're building and then how it works. So internally, all organizations will have their own internal network. And like I mentioned, they're going to be running their own routing protocols so they can find stuff. That's how they build them out. And they're going to be connecting to the cloud too. And you know what? If you don't have a path to the cloud or a route to the cloud, you can't reach it. So Imran's going to do some tuning on the cloud. He's going to set up the connections. And at some point, he's going to show you how we traffic engineer or prefer one like or another. He's at some point going to connect us to the internet and a second cloud. So it's going to be fun. So Imran, back to you.
Yeah. So basically, the purpose of border gateway protocol basically is having two different autonomous systems in two different companies, and within the AS you're running IBGP. So within the AS you run IGP, and so EBGP and IBGP. How we redistribute if you're running OSPF here to IGP, we'll do that, and how we advertise on IBGP and what is the difference, what are the advantages. BGP is the exterior, EBGP is the main protocol, exterior gateway protocol, and IBGP basically is helping to have helping for EBGP to make it work basically, because if helping to reach the edge network, the IBGP, because if you redistribute from OSPF to EBGP to BGP and from here to here, and how it's reached to the edge, it will change the attribute for BGP. That's why we run IBGP. So I must say it like EBGP is the main protocol, main routing protocol, and IBGP is the one who's helping it. So I must call it like EBGP is like a Batman, and IBGP is just helping him to make it work. So that's the key thing. Is Mike, you want to add something?
Yeah, thank you for doing that. So when we're dealing with cloud, the cloud is external to us. They are external entities. And because they're external entities, that's why we're using this exterior gateway protocol, or EBGP. So when it comes to the cloud, it's 90% EBGP. What IBGP does, which is really helps EBGP, is let's say I've got a lot of routes to a destination. Let's say, for example, I connect to 10 different internet service providers. I've got 750,000 routes from 10 different internet service providers. If I want my network to have the intelligence throughout the entire network, so that every router in your network knows the most efficient path on the way in and the way out, you have to run something called IBGPs. And that's basically carrying the internet's routes inside of your organization. Why can't you do that with OSPF or EIGRP or intermediate systems to intermediate systems? Here's the reason. They're not meant to scale to that many routes. So what you'd have to do is you'd have to take all the routes out of BGP. You'd have to do something called redistribution, which would be taking them from BGP and putting them into OSPF. And then you'd have to define metrics for them. And then your OSPF routing table will swell with all these what's called E2 external type 5 LSAs. And what's worse about it is every time something happens in your network, you're going to have a recalculation of every one of these routes, which is going to send your CPUs to the moon. Your routers will crash. So EBGP, connect to external entities, IBGP to help it out along the way, IGPs for network layer reachability to make BGP work. And you're going to see that when Imran does it. If you've got no IP connectivity, you have no BGP. So I've seen people that were trying to write cloud networking books that said BGP is the only routing protocol in use today. There is no BGP without network layer reachability. So Obviously, there's more than one just protocol. So Imran is going to help us do this. We're going to start configuring this when we do this by going to the network. So we're going to first start with AS200. Now, Imran, did you design IP addressing schemes for these things yet?
Yeah, it's already in here.
They're already put there. Okay, that's totally fine.
Yeah. So I'll explain what is it, just for easy for we used to do this in our CCI lab. So just to reiterate, Mike is IBGP, because if you're learning something from AS100, it's coming to AS200, and it's need to reach from this edge to this edge. That's what you need IBGP, because when the route's coming in from AS100, you have a AS number, and the AS path is used for loop avoidance. So if you change the AS number, it will change the attribute if you don't use the IBGP. So from here to here, because you learn something from here to here, and from reaching to the edge, you need IBGP. And of course, IBGP is overlay protocol. You need to have IGP learn to exchange the information, and and we are talking about routing protocols. Routing protocols is about who is doing the exchange, not routed protocols, because people got confused. Routed protocols are IP, IPv6, AppleTalk, IPX, and SPX. And routing protocols are OSPF, ISIS, RIP, and BGP. So
perfect. So, one thing before we move on to the configuration, I want you to notice this. So this is real internet routing that we've set up here. So let's say on the left of your screen, you see AS100. And on the right of your screen, you have AS600. For AS600 to reach AS100, it's going to have to go through AS200. Does everybody see that? So Imran will show you. If he points his mouse to AS200, which is kind of that like cream tan color on the left, that needs to send routes to AS200, which is kind of the light blue in the middle. And those routes need to go to AS600. And if AS600 passes its routes to AS200, and AS100 knows of AS600 routes through AS200, guess what? AS100 and 600 can talk to each other through AS200. Now, if we want this to work, this is fantastic. And this is why we use BGP. But what if we just wanted to learn the routes from AS100 and we didn't want the rest of the world to come through us? If we passed AS100 routes to AS200 and 200 exported them to AS600, AS600 could reach AS100. But if we didn't want AS600 to reach AS100, all we would have to do is take in the routes from AS100 into 200 and not export them. So there's the concept of no export. If you don't export routes that you learn from someone else, you won't become transit for someone else. So when you're dealing with AWS, for example, or these cloud providers, they know this. They also know that not everybody's a BGP expert. So if you don't know BGP and you take in your routes and you export them to someone else, what happens? Typically speaking, the company becomes transit for the entire internet. And AWS knows this. So if you peer with one VPC, they don't pass your routing information to the next VPC because they don't want you to become transit for the whole internet. So just understand those kind of things while we're doing things. So that's why in AWS, for example, they've got all this non-transitive routing. And how do we break those rules? We use things like Cloud Hub or Transit Gateway, which are basically route reflectors, which we'll show you later. But understand the difference between transitive routing and non-transitive routing. As it stands here right now, we have transitive routing because this is normal BGP routing. So Imran, if you want to try and go to AS200, maybe show the people what these routers look like. We'll show how we configure them. I'll explain what you're actually doing, unless you want to explain what you're doing.
Let me put the basic config. Let me restart the routers from this. Let me show the people how we can wipe the device and all the device. I'm just so easy. If you can see, if you right click on it and you can wipe it and you can start it. Once I wipe it, I'll start all these devices. So
So much less work in a simulated environment to do these things than
Yeah.
in a production environment.
Yeah. So let me connect these devices. I think I already have one.
While Imran's setting up this topology, anybody have any questions for me? Oh, it looks like you're probably almost ready, Imran.
No. Give me 1 second, Mike.
Okay, so let's do this. Once they've got the cleared routers, let's walk everybody through the basics of what they see on the Cisco router.
Absolutely. That's what I want to see.
Bear with us, we're building stuff real time. So when you build stuff real time, it's always a fun challenge. But Imran and I have been doing this a long time, so we'll have fun with it.
Just booting up.
Yeah, these routers do not boot themselves up in 3 seconds.
Yeah. No, it boots up very fast. So
They probably boot faster here than they would in real life because it's got a much bigger CPU. Imran, yes, we will leave a recording available after this session. Definitely.
it's boot up like this mode. You want to enter an initial configuration, yes or no, say no.
This would be like an auto questionnaire. It would walk you through things. Nobody uses this.
Yeah.
So Vikas, what you have to do when you get these kind of things is you have to have the iOS images to put there. Basically, they're like little mini virtual routers, and they use the Cisco operating system. And that's why they're using to do such a good job for testing, because it's the actual iOS operating system. And yes, it was called iOS about 2 decades before Apple decided to use the same term.
So don't worry about this RAD thing, and that's just I'm using a software to simulate better, and you don't have to worry about this. Not errors from the router. So bear with me, Mike.
Take your time. You're doing great. I want people to get to see how all this is built. When you get in there, these things, I want to walk them through what you initially see in the console port before you type enable, and those kind of things. Just so people that are not used to working on Cisco routers every single day kind of get a feel for it. I'm not going to say the Cisco router command line interface is necessarily the most intuitive, even though for me, it feels pretty much normal because I've looked at it for so long.
Yep. That's all we do every time. So
yeah, pretty much. Now there are ways to do some of this stuff with API calls, but when it comes down to it for some of this stuff, we're just going to be getting on there. Okay, so wonderful. And now, you all wiped off?
I think it's just R1 and R7. Yeah.
The name of this simulator is EVENG. There's a couple of other good simulators that are out there. Cisco's got a viral one that they use. There's another one. Is it called GN3 or is it GNU3?
GNS3.
GNS3. That's another good one I've used with some of my students, but this EVENG is the most fully functioned, full capability. There's a freeware version, which you can use that's quite excellent. Today, we're using the professional version, and the reason we're doing it is Imran and I do CCIE work or CCIEs, and we get pretty deep on these things. Plus, we've got students that need to train on networking. And because we have students that need to train on networking, we need the industrial grade environment. So, realistically speaking, this is what we're talking about. And then when we install things like loopbacks, we'll talk about them. We're going to make everything in these routers clear to you what we're doing. So while we're erasing router configs, anybody have any quick questions? See, we're going to brand new routers over here, meaning no configuration, and we're going to do it from the beginning to beginning. You're more than welcome, Mr. Andre, but if you've got more stuff, anybody's got any questions while you're out there waiting for Imran, type networking in the chat box so I know that you're not asleep. John Elho, I'm not sure what you mean by Cisco CML2. But if you want to spell it out, happy to help in any way.
So these all these routers are up. Let me show you the version.
Before you type enable,
yeah.
Can you go back to the base mode?
Yeah.
Okay, so when everybody logs into a Cisco router, here's the first thing that they're going to see. They're going to basically, if they're plugged into the console port, they'll see something called console. And it'll say return to get started. Now, I want you to understand when you start out, you're going to see router and you're going to see that greater than symbol. That greater than symbol basically means you are there with basically user access, meaning you can do a little bit of looking and showing a little bit of things, but you can't actually do stuff. So that's the difference. You can see stuff, but you're not going to be able to configure this. So the next thing Imran's going to do when he wants to be able to manage this or manage this router, he's going to type enable. And enable is going to give him privileged executive mode or basically root access to the router. You want to type enable, and then what we'll watch is going to turn from a greater than symbol to a pound. Now, what you can actually see is you can see the software version. So Imran, I'll go back to you. And this is going to give you a lot of information. You're going to see which version of the operating system we're being used, which is 15.4. Oh my God. When I started, I was starting at versions under than 10. I think it was 9.3 or something like that. So we've come so far over the years. You can see when the software was compiled on October 8th, 2015. You can see the router has been up for 3 minutes. And you can see the warnings about cryptographic things. And it tells you exactly where the routing image is. You know, it used to be in Flash. Now you notice you've got Unix and Linux systems. So operating system's a little different. So there you go. Kind of right. Yeah, it's exactly what we're doing here. We're paving the way. So now I'm showing what's called the running config, which is what's actually going on the router. So if you type show run or show running configuration, you're going to see some defaults. First thing you're going to see is the version. And then we're going to see, you know, different things related to passwords and encryption. For example, we're not encrypting our password here yet. The version before that's here. You also talk about certain timestamps and certain kind of like syslog messages that you're going to get. Then it says no AA new model, which basically means we haven't started any kind of authentication or authorization accounting yet. It tells us which time zone we're in. And regarding SNMP, that's for management, simple network management protocol. And then you can see that we've enabled something called Ceph, which is just a type of switching in Cisco. Imran will keep going. Okay, now we've got interfaces. So what is a router? It's a computer with a bunch of arms on it. Send your traffic in this direction, out your interfaces, which are like your arms. So you've got some. Notice by default, out of the box, the interfaces are all closed. Meaning if you plug a cable into it, it's not going to work. Meaning it's secured, locked down. And it's got no IP address, which means it won't work. So in order to use these, Imran's going to have to put an IP address on them and turn on the ports, which he's going to do. But I just wanted you to walk through the defaults. So we've got no web servers turned on by default. The line con is related to the console port as if you plug direct in. Line VTY04 is related to Telnet, for example. Line aux, these routers typically have an auxiliary port. And, you know, you can call a modem, you know, one of those old things that uses a generic phone line, and it negotiates this thing. And then you can be plugged in and configuring these things from thousands of miles away. I did it all the time. Why do we do that? If you've got IP networking to it, you can telnet or SSH. If you've got no network, You can't configure it. So replace the modem, call the modem on the other end of the line, if you can even believe this anymore. And then we're on the port and we configure it. Once it's got IP address, we switch over to SSH or Telnet.
Yeah, so just to add another point here, the tool you're using for SSH is Secure CRT. Yeah, so it's about Secure CRT. That's what tool I'm using. I have a license for it. And that's what I'm using. But there are other free tools you can use for PuTTY and other CLI coming with your laptop. So normally, typically PuTTY and as Secure CRT is widely used. I like the Secure CRT I've been using for more than 10-15 years. So okay, so just to understand the addressing scheme here, Mike, so maybe you can add here. So I have a R1, like R1 having a 192.1.17.0 network, and when it says this is zero network, so the IP address for E00 will be on 17.1 here on R1 and 17. Of course, this is like a totally a different signal, but that would be the typical thing. 17.1 will be the IP address for that network, and that there are a few loopbacks I'm advertising because of we need to do that. And if you go on the right hand side, this is the network you're trying to reach. We'll add some static routes using this to reach that loopbacks. If you say like it goes in the top one, like 192.1.34 net 35. So 35.5 will be this interface, and 35.3 will be this interface, and that's what we have a connectivity. So similar fashion on the right hand side, 1.46, 46.5 will be R5, 46.4 will be the R4.
Excellent. So one quick thing, when Imran mentioned the word loopback, so with the router, you can configure a logical interface. It's just logical. It doesn't really exist. And typically speaking, we create what's called a router identifier, and it's the loopback address. So we basically pick an address. It's typically a /32 because we're not going to have any hosts on that subnet. It's just that thing. And we use it to basically promote reachability between IP addresses. So that's what we're doing. And it's an identifier. Each router has got a loopback. So Imran, back to you.
Okay. So first of all, we'll configure this edges R3 and R5. We'll put basically the basic config in all the devices with IP address, direct connected IP address, and the loopbacks for R1, R2, R3, R4, R5, R6, and we'll put over there and we'll paste it. And once we have the basic connectivity and interface are up, we will be configuring this EBGP here, EBGP here, and of course EBGP and the multi-hop. And then once these are things up and running, we'll configure this portion. So we go step by step. Ask any question if you have anything to ask. So I'll go for R1. I think
before you do R1, Chintan had a quick question.
Yeah.
Chintan, if you want to go back to the picture real quick.
Yeah.
Not to get in the way of your flow, because you're doing so wonderfully, and I'm so grateful. So what Chintan said, look, I'm not necessarily sure what I should do things. I came a few minutes late. So I just want everybody to look at this in case you joined late. I know on YouTube people pop in and out, and that's great. Autonomous System 200 in this environment is going to be our data center. So our organization's personal data center is going to be AS200. AS100 is going to be the cloud that we're connecting to, and that's what we have redundant links. AS500 is going to be another internet service provider, and AS600 is going to be a second cloud that we're connecting to. So now you know what the architecture actually is. For those of you that came a little late, I don't want anybody lost. So we'll talk about why we do EBGP and IBGP when the time comes, but Imran's going to go back to setting up the first router. So let's build it.
Let me use the notepad.
Notepad is great.
Yeah, so because you can have a copy and paste for the
when we build the documentator, when you type these things, I'm going to explain what you're doing.
First of all, the host name, then of
The
course.
host name is going to be the name of the router that it's going to be identified as. Right now, he's basically creating a logical address called loopback. So, and he right after that, he's going to put the IP address for it. And he's going to have an IP address for the loopback. I think it's
Sorry.
yeah, there you go. So then loopback 0, and then see, when you've done it this long, we literally type our configs literally in Notepad ahead of time. Because we don't have to type the full word. It's basically going to do this.
I just want to show them. I have the config. I just want to show them the audience. So.
Okay, then I'll turn back to you.
Yeah.
I want to get in your workflow. You're doing really fantastic.
Yeah. So basically, I have these are the interfaces. I have a loopback 0. I have a loopback 1. I have loopback 99, and of course, if you see I have E00. E00 will be the yes, E00 is 192 1.2.12.1 12.1 E00. I think I just reverse it here.
E00. How old is this? Is this kind of what router is this?
We have a gig interface as well, so just
Okay.
to make it simple, understand the terminology. So
I was just asking the question. We used to have interface E0, which meant 10 megabit Ethernet, FE00, which meant 100 gigabit, and then GE00, which meant gigabit Ethernet. So just shows you how long I've been playing with the stuff. Watch what he's doing and watch what it's going to change. Now, some of these interfaces are going to come right back up. Some of them might actually have to be turned on.
So show IP interface.
Oh, that's new. You used to have to exit out to do show up IP and brief.
Yeah, no, it's been a while. Yeah. So
Yeah,
you can so you can see the E00, 01, and the loopback. I have 3 loopbacks. Loopbacks is just a networks. We use it for some other purpose, advertising some to basically now do save, show right mem.
So write mem basically means save the configuration.
Okay, go to the.
Could also be the same as copy running config to startup config, but we all type write mem. So right now, all we're doing is we're going to put the IP addresses on these devices. And after we do the IP addresses, we're going to set up some routing, but we need basic IP connectivity first.
Absolutely. So R2 have a, like if you see on here, R2 have this interface. There are so many interfaces. So let's put it together. I have the config ready. So all the connected interfaces are up.
Okay, now look at this real quick. These are the actual interfaces that are up on the router. So note, every interface has to be on a different subnet, which they are. Also note that it says up. So when it says status up, it means the interface has been turned on. And when it says protocol up, it means the data link layer is up. So this is completely up.
Okay, look at the,
You know, Imran, I'm watching you configure these routers and it's making me feel like I'm 20 years old again. So we go type something, configure something. Makes me feel young.
I always use Notepad so we can replicate and changes. Highly recommend to use.
Notepad is the right way to go.
Yeah, because in CCIE, we have to do so many devices at the same time. So and this is time sensitive as well. And you need to replicate a lot of things. And even on the production side, if you do some errors and issues, you can do that as well. So
Always better to have your configurations planned, your IP addressing done. When you get there, where you give your configs to an implementation engineer, whatever the case is, plan it out ahead of time. Now, the networking, look, it's not like there's a pretty management console or something like this. So you really got to know it in here before you go somewhere else.
Any question, Mike?
And so, Imran, can we have these text files as well, please, after the session? Look, we could probably make the text files available for you and happily to do so. But I'm not necessarily sure what the text files will actually do without the actual topology and understanding the architecture. So if it's something you desire, Imran, I'm sure we can do it. Happy to set that up. Maybe you want to do that and then kind of use that along with this. I think that could be completely appropriate. If that's something you desire, we can kind of make that happen for you. So
basically, I think the pasting the config file just to save the time perspective, and you can build your own lab. And I think the concept is just trying to understand how the network configure and how you do the router. What are the things you need to look at? I think that's more important. You can change any IP addressing. You can build your own labs. That's very easy for the tool.
So I think what we can conceivably do, Imran, I'll have Chris or my team investigate it. Chris is a whiz at figuring things out. Can we take these text configs? Can we take a picture or a screenshot of something like this? Can we place it on a cloud drive and share it in the description of this video for you to go and do it? Would that be helpful to you, Imran? Because I want to make sure we give you the tools to be successful. And if anybody has any questions while Imran is doing some configurations, please feel free to ask. He's doing the build, for the build, but any questions, I'm here. So anyway, I can help along the way while Imran is building us a system.
So now on an R5, if you see on an R5, so we'll configure the BGP, EBGP between R5 and R3. And let me show you the config before I paste anything. Basically on R5, if you see the AS number, when you configure BGP, you need to define the AS number. So R5 is like router BGP AS number. You have to define the AS number, and BGP is like a unicast protocol. So if you want to pair, with your neighbor, you need to define the neighbor. So if you see that the neighbor is neighbor 192.1.35.3, that is the neighbor for R3. 35.5 is the R5. So you're putting a neighbor statement telling them pair with this. So BGP doesn't work without the neighbor relationship. The other thing is you're advertising the loopbacks we created too. So let me show you show IP route. So if you're seeing on the routing table what exactly we are describing and configuring. So we are advertising. If you see show IP route, we are advertising the 5 network. So what's seeing on the routing table, and we are advertising the 55 network. So the reason is we are putting this 5.0.0.0 without mask, which is a default network is connected over here. And the reason we are putting this the mask is a subnet, not the network here. So
okay, so realistically speaking, that's the subnet. So I want you guys to all look at this. Notice with every route, you're going to see something. It's going to identify it. C means directly connected. L means like basically local to the router or loopback.
So, that's
soon we're going to have routing, and we're going to be seeing things from BGP, maybe OSPF. We're going to show you how those routes are different. And then at some point, once we've got it up, we'll just start adding interfaces and advertising them, and we'll show you how this routing propagates through the network. That's where the magic begins.
Yeah, so we'll paste this config on R5.
What are you typing in next?
No.
The BGP sessions?
Yeah.
Awesome. So
the one
of these, when you do it, I'd like you to do a debug IP BGP so people can see the finite state machine come up, open, XOR, that kind of thing. Not for this one, first one, but just one of these, I wanted you to do that.
Yeah. R5, and then if we go for, because it's not configured yet, we have other neighbor R3. So if you go to the R3, you can hear me clearly, Mike? You can see me clearly?
I can see everything you're doing. I'm looking to saw those interfaces come up. I saw you configure BGP on the other one. Let me explain what you see here. The neighbor is the person on the far end you're going to put you establish the TCP connection with, and the remote AS is their autonomous system. The network is basically something that all encompasses what you're going to put there. And
so on the other side on R3, the AS number is 200, and the neighbor will be the 500. If you see the compare the config, and the neighboring IP is 35.5 because which is here 35.5, and it's all opposite, vice versa.
Okay, so everyone, I want you to really see this. The top one says router BGP 500. Yeah. That's an autonomous system, router BGP 500. The bottom router says router BGP 200. No, they are different numbers. Because they are different numbers, this is called EBGP or external or exterior BGP. Note, if they both said router BGP 500, it would be a BGP speaker on autonomous system 500 connecting to another BGP speaker on autonomous system 500. That would be IBGP or internal BGP. So when autonomous system numbers are different, external BGP. When they're the same, that's all in the same family, it's internal BGP. Back to you, Efra.
Yeah, so one very important point I just want to reiterate here, Mike. What exactly we are doing for this network statement? We are advertising the network. We are injecting the routes into the BGP. So there are two ways to do the injecting the routes. Either you advertise the network or you redistribute from somewhere else. So just remember, but there is a big difference when you're advertising the network in IGP versus a BGP, because when you're advertising network in IGP with the network statement, it means you are advertising the local network, which is connected network. But in IGP, network can be anywhere. So just remember, it's a very important concept, the network command difference between IGP and BGP. So here, network is advertised remotely. It can be other network, but what is it? What you're advertising? What you're seeing on your routing table?
Okay, so I want to really reemphasize and hit that part hard. When you're typing a network statement into BGP, you are saying BGP, give this network information to somebody else. When you're putting a network statement into OSPF, what you're really doing is you're telling which interfaces you want to participate in OSPF and form a neighbor relationship like, hello, are you there? Are you there? Are you there? And the far end says, yes, I'm there. And then they start establishing neighbor adjacencies and start exchanging routes or LSCs based on the protocol. This is different. This is you're saying, I have this network somewhere in my routing table and send it to somebody else. Even if the network is not connected to me, it's in my routing table. With the IGP, it's enabling that routing protocol to talk on a certain interface, like an ARM, to other people that it's directly connected to. So that's kind of the thing. So Imran, back to you.
Absolutely. Thank you, Mike. That's very important.
Thank you. You're doing a great job of showing people how to use this. I'm so grateful. Now
we have go show both do BGP summary. You see, so we have a neighbor relationship, but so I'm on R3 and I'm seeing a neighbor relation between 35.5. What AS is very important. This is a this attribute, very important BGP attribute. It's used a lot of functions. It's the two key functions of AS attribute is the loop avoidance is the main thing. It'll help to have a loop avoidance from some BGP perspective. So if you see, I'm not seeing any prefix, even it takes a while. What the zero means, we have a neighbor relationship, it's up and running and working, but you're not seeing any prefix, what we advertise, the loopbacks. So it takes a while to come back. So if you see now same thing, you're seeing two prefixes. So you're learning two routes from the R5. Show IP BGP summary. Here in R5, you're seeing the two prefixes and your neighbor were AS200. And the other command to verify to show IP BGP. You see, you're learning the three network. What is the next stop? Will be 35.5. 35.3 is your directly connected interface. We'll talk about later. And what path is coming from? Is learning from AS200. So what is this 5.5? 5.0000 means it is a local route. That's a loop, one of the loopback we created to show IP interface brief. See, it's one of the loopback 0, and we're seeing is next stop is 00, so means a local route. The other loopback.
No, one thing. Note the route that you see in the routing table, the BGP table, is 5.0.0.0. Note the loopback that he used to have that subnet on the router is 5.5.5.5, which is most likely a /32. So he's advertising something because he's got a route in his table that reminds you. So with BGP, it's not necessary to necessarily advertise the most specific subnets you need. You may just want to aggregate or advertise your aggregate or your site or range or a summary route. And that's what Imran did here. So I just wanted everybody to understand what's going on. Back to you, Imran.
Thank you. So run, let me show you the BGP.
Oh, this is the new Linux version.
So you see what are the commands we are advertising? What just Mike described. We don't have. We are advertising the network. We are advertising the two loopbacks and then the neighbor. And
soon, when we get this all configured and all built, we'll actually have some fun. We'll install a loopback, and we're going to show you how long it'll take to propagate across autonomous systems, which is why we'll say that BGP is designed for scalability. Slow it down. Ask it to do less computational overhead, scales to more routes. You couldn't possibly put 750,000 routes into OSPF, but you can easily take in 750,000 routes from 10 different internet service providers in BGP. No big deal. Now notice how the routes learned.
Yeah.
So let's walk you through two things over here. Note, you've got the 3.0.0/8, which coincidentally is an old-fashioned Class A address. You can also see that the 33 subnet is actually /24, which has been advertised. Note that you see a B next to them. And why is it a B? Because it's learned via BGP. Note, there's this thing over here which says 20. Cisco made up this concept of administrative distance. What is administrative distance? It's how believable it is. BGP is a highly believable routing protocol externally. So it's got a 20. The higher administrative distance, the less believable. The lower the administrative distance, the more believable. It's kind of like a friend. If I call Imran and say, Imran, I had a network problem in my house. Can you come over and fix it? I'd be totally comfortable with giving Imran the keys basically saying, here's the passwords of my systems, go fix it. And you know what? Because I know how capable he is, I know that I could go to the beach, teach a yoga class on the beach, maybe finish the yoga class, have lunch, come back, and it's good. Well, BGP is so reliable. Cisco has said to give it an administrative distance of 20, meaning if you get the information via EBGP, believe it. Now, IBGP has a lot more complexities, and it's got a much higher administrative distance. It's 200, right, Imran?
Yep.
For IBGP, meaning Cisco thinks it's 10 times less believable. Back to you, Imran. I just want to kind of try and walk people through the things as we're teaching.
So few important commands, verification commands, just for the audience. There are a number of commands, but few important commands. I just want to type it here. True IP BGP summary and so show IP BGP summary and show IP BGP, and of course I run this show IP BGP, show IP route, show IP route BGP. So that's two verification commands. So now if you're seeing, we have completed this EBGP session between these two. So we'll repeat this.
Okay, on R4, let me remember 1 second. We've had some new members subscribe, and when they just popped on the call, they said, I'm not really sure I understand what's going on here. So I just wanted to walk them through the topology, that if you show that map one more time real quick, I'm trying not to get in the way of the workflow. AS200 for the person that just subscribed and asked questions, that is our data center. AS100, which we're going to connect to at a certain point, is the cloud, and we've got 2 direct connections to the cloud. AS500 up top is an internet service provider our data center is going to connect to, and AS600 on the right is going to be a second cloud. Say the left side of it, AS100 is going to be AWS. Say the right side of it, AS600 is going to be Azure. I'll go back to you, Imran, but just periodically people jump in and they have questions, so I'm going to try and answer them.
Okay, so we have finished this R5 and R3. We'll go to the
Yeah, they got to make things stop looking like each other icon-wise, so we don't have to keep clicking the wrong ones.
Yeah. I don't want to paste somewhere else. So
I do it all the time.
Yeah. So now we go to the multi-hop kind of a thing. Where's my So the other thing we can do, we'll configure this later on. We can have a authentication as well.
Yeah, great.
Yeah. So we already have a neighbor. So if we go to the R4 and R5, so this is R5 and R3. So BGP or the BGP 600. One second, Mike.
From feedback from the audience, Sujit, one of our favorite cloud architects that we know, is texting me to say how much of a great job you're doing, Imran.
Thank you, sir.
So I'm not normally picking up text, but when it comes from our internal team members and others in the community.
So we'll go to the multi-hop. We'll configure this R1 right now. We'll configure we go to R1. We have the the basic config. So just want to add here a point. Basically, if you see on this allowing, we have two connection here with EBGP, and of course the two different system, different AS, this AS100 and AS200. When you configure the neighbor relationship, by default, it is not multi-hop. So you need to enable a multi-hop basically in order to have this connection. Basically, EBGP always by default comes with the directly connected interface, and here we'll configure this EBGP neighbor relationship between using the loopback. But first of all, in order to reach the network an R1, you need to define, in order to reach the loopback, in order to reach the network, you need to have a static route, some kind of a reachability, and then it's going to be worked in that way. So let me configure a route. So I'm configuring two static routes from the R1 to reach the reachability of the loopback. So 11.2 and 11.2 is the E01. Yeah, and 11. Let me verify it.
To note what he actually did in these routes, IP route tells you the destination that you're going to with the subnet mask that you're going to, and then he put the next top IP address. So that's what was going on there.
Yeah. Ethernet 00 is 12.1, Ethernet 0 is 12.1, and Ethernet is 11.1. Yeah. So I configure I configure to 2.2 static route to reach to the next hop, 7.2, which is the network here, which is my network here on R2. Any question, Mike?
I think you're doing a really great describing this. I want to point out one other thing.
Yeah.
So when he did the show IP interfaces brief, notice you have Ethernet 00 that's up and it says manual. Notice that it says Ethernet 0/2 and Ethernet 0/2. Note that it says administratively down. When you look at these things, they are shut down. And if you want them to be unshut, these interfaces, as you noticed, Imran did a no shut. So administratively down means it's manually down because the person didn't turn it on.
Okay. So now we configure the BGP configuration. Typically, you learn so this is the router BGP 100, and you're configuring this 198.168.2.2, which is a 2.2 is a, let me show you. 2.2 is a loopback. Is a loopback here. So you are configuring this AS100 via the loopback, and as I said, the BGP always enable for directly connected interface. This does not allow a multi-hop kind of a concept. So in order to enable that, we need to add another command by having a neighbor, specifying the neighbor, and by adding an EBGP multi-hop. So Mike, what do you think? Is the configuration is complete?
I think so.
Yeah, I still have one more thing because we are configuring the neighbor, and neighbor is reachable by static route, and it is not the next hop. It is a multi-hop. So I put
Okay,
this
yeah.
command. And other thing is, because we are configuring is via loopback, so we need to have another command, neighbor 192.168.2.2 update source loopback. Seeing the command, Mike? Yeah.
Yeah, I totally see what you've done. Okay.
Yeah. So because the reason is this difference from this EBGP to this EBGP, this is not directly connected interface. This is we're doing this loopback. The reason we do this, your network is not always directly connected. You might have a firewall. You might go through the firewall. So the reachability, as long as your loopback is reachable, the perfect use case now would typically to have a firewall somewhere in the between two areas. So the reachability is there. So you configure based on the loopback. And based on the loopback, we need to have a few extra commands telling EBGP to have a multi-hop and update source loopback to what I did here.
Perfect. Yeah, normally we just do EBGP directly over the connection. And we're not as far, we don't have to do any update source loopback. It's just neighbor on the far end of the IP connection. But, you know, and also you have to make sure that that's reachable, because what you noticed, he added these static routes. Why did he add these static routes? If the next hop becomes unreachable because you don't have a route to the next hop, the route may be in the BGP table, but will not be placed in the routing table. So that's why he had to put a next hop static route to the loopback addresses for the EBGP multi-hop.
Yeah, that's for the reachability perspective. So I agree. So we'll do the same thing on the R2. Any question, Mike, from the audience?
Let's ask the question. Everybody out there in the audience, we're doing some heavy duty networking. We've configured 4 or 5 routers. We've done some static routes. We've done some BGP configuration. We're having fun with this stuff. So if you guys have questions, please answer them. We'd love to take your questions. All we want to do is help out. So if you've got questions, please bring them in. I know this stuff's kind of complicated. I've already spoken to Imran, and we're going to build this step by step. So this week we're building a base thing. We may come back in a week later and teach you some fancy traffic engineering or some route reflectors 2 weeks later. So if you want more network stuff, type network training in the chat box and we're going to do it for you. And, you know, if you've got any questions you'd like us to clarify, let us know. We want to be your source for information. We want to give you this information. We want to help you get to your goals. So let's get to your goals. Libra, fantastic. We love hearing this. Can't wait till you start. And I got to tell you, this networking stuff is really great. Dram, you're right. A loopback address is virtual and it will never go down. Let us know by typing network if you're loving the networking stuff, and we will produce so much more networking content and we'll get you there. Nick Love, you said networking. Libra, you said networking. I got to tell you all, I am Alonzo networking. I am having so much fun doing these kind of live training sessions online. Reginald, Jam, wonderful. I literally spent as much as a car would cost to buy some new special streaming gear, and it's going to be here in the next few days. We are going to have a daily show. We're going to talk about cloud things, networking things, what's going on in the community. We want to be really hard to give you guys some extraordinarily good free training. And for those of you that want to participate in our paid training programs, I promise you, it'll be a life-changing experience for you, because what we put in what you would consider to be a day's pay for the cloud architect, somebody else would charge 20, 25,000. We teach executive communication, presentation skills, architecture skills, the network, the data center, everything. So you want to work with us directly? We love to work with you. You want to reach out to us and use some of our free services? We're excited. And if you want to do both, that's great too. All we care is that we help you get to your career goals. So ask your Queen training. I see you guys, a lot of people are liking the networking. And guess what? We're going to be doing a lot more networking training. And I'm going to make sure to bring my expert and good friend Imran with me on a lot of this stuff. So I'll make sure you know it from the best and the brightest people in the world that we can find.
So Mike, you're seeing an R1, 192.168.2.2. which is the loopback here, I'm seeing two routes, ECMP equal cost load balancing. So the reason we might have a similar case all the time, we have two links, and I'm seeing two routes. This route is learning from 12.2 or 11.2. You want to add something here? Yeah.
Okay, so let's look at that. It says S, and what does S mean? It means it's a static route. Note that 1, the administrative distance of 1. You manually told that router, hey, to get to this route, here's your next hop. It's pretty darn believable because you manually told it that. So it's got an administrative distance of 1, which is about as low as it gets. So that means reliable, reliable, reliable. Note, he put 2 equal cost static routes in, and that's why you see 2 routes to the 192.168.2.2/32 subnet, because he has 2 equal cost routes. If he had one at a lower cost and a higher cost, and he can change that if he wanted to change the metric to the route, you could see immediately it would change that. But 2 equal costs, therefore that you're seeing what you're saying. Okay, now what is this showing? Explain that, Imran.
Yeah, so I'm learning. I'm sitting on R1. I'm learning a 2 network, and the next hop will be 2.2. And so we're learning 2 networks, and we're learning AS path 200.
Now R1, where's the location of R1 so we can answer Muhammad's question?
Yes, R1 is here.
So R1 is there. We're not going to be running OSPF. We will be running OSPF to the multiple routers in that area for network layer reachability. Absolutely. We're also going to be running OSPF in all the in local areas for network layer reachability.
So we will be running OSPF from R7 to R1, that's yes. area 0, and then we'll show them the redistribution, how the redistribution works by a network statement and by redistribution OSPF ASPF area. And
fantastic. And after we build it, I'm going to have you show people if we change the weight on one side, prepend another route, change the local preference, set a community on one side, match that community with a route map, and change the weight. We'll play with it. We'll show some tuning capabilities. But first, we've got to build it. Hope we answered your question there, Mohammed.
Is it good?
It's great.
Okay. So now go to the, we see we are having R7 and R1. We are running the OSPF. We will run the OSPF here. There's nothing on R7. Just add it. We'll add the host name. So we'll configure Ethernet 00, and we'll use the 70 network. Basically, it should be here.
Okay, so let's everybody see where R7 is real quick, just to make sure. So note R7 that's where going to be our cloud VPC. For example, R7 will be running OSPF to R1 for that internal AS 100 network layer reachability information.
So I'll configure the E00. No check. I configure loopback 0 and loopback 1. You see, I define the IP OSPF network point to point.
Yes. I'm going to explain to them why you did that.
Mike, I'll ask you to explain for the non.
Sure. So typically speaking, OSPF, generally speaking, is a broadcast multi-access. It sends an IP multicast hello to 224.0.0.5. It says, "Are you there?" Like a health check. Are you there? Are you there? and it listens to a hello from somebody else. And when they form what's called the neighbor adjacency. And after the neighbor adjacency is formed, they send LSAs. Now, if you're on a broadcast multi-access network like Ethernet, you have what's called a designated router, which basically is the primary router for that subnet, and a backup designated router. And those two, for what it's worth, listen on 224.0.0.6 for multicast and LSAs and things like that. So point to point is because basically you're sending it over a point to point link. And because of that, you're basically saying how you want it to form a neighbor adjacency instead of just a multicast hello, like you would use in a broadcast multi-access network.
Yeah. Thank you.
Jeannie, I love to see the enthusiasm on networking. Jeannie, I love all the enthusiasm and all those wonderful things that I see when we interact on a frequent basis.
So I'm configuring the OSPF. I'm advertising the.
Okay, so what he's really doing here with OSPF, when he's putting in this network statement, that 192.1.17.0.0.0.255, he's basically saying add all interfaces that match 192.1.17 and anything else in the last talk about. Bring those interfaces into area 0. Turn on OSPF. Start saying hello, hello, hello. Start establishing relationships. And then after those interfaces start there, they will start advertising their links. OSPF is a link state protocol. Basically, LSAs are flooded and everybody sees the state of all links. Then the routers use the CIDR algorithm and they run a shortest first path calculation. And then they say, to Imran, that way, to Chris, that way, to Jeannie, that way. And that's because they're coming on the network because Imran turning them on the interfaces, and those interfaces know to participate, and those interfaces know how to advertise their links. Perfect, Imran.
So I'll go to the R1. We have
Yes,
to do
please.
the R1, the same config. So there are two networks we are advertising. One is the directly connected Ethernet and the loopback. So I'm configuring E02, which is a directly connected interface with OSPF.
So that's the link between the two.
Yeah, R1 and R7. Just putting the IP address and no shut. And then, of course, I add the OSPF. See, the links are up. And I can put the OSPF config, area 0.
Now you're going to see the fun on R1. If R2 is configured with OSPF and R1's configured with OSPF, okay. Guess what? We're going to start learning some routes via OSPF soon. Nope. Yeah. Okay, so what do we see here? We can see that the router is full, and it's also the designated router. So we know the neighbor is in charge on this section. It's the designated router, which means we could probably be the backup designated router because we're the only other router on that subnet, but we're not sure yet. And that's the designated router. We will be listening on 224.0.0.6 for LSA advertisements, even from them, even though LSPF routers are 224.0.0.5. So Imran, do you want to show what the routing table looks like? Well, first let's show people where R1 is in case they forget. In case anybody is like me with a short attention span, if you can show them where router 1 is in the topology and which routes it's going to be, and it's going to be learning routes from router 7 over that Ethernet 0/2. So let's show people what the LSA database looks like. Let's show people the routing table. Let's walk them through it. Okay, we're on router 1, right? Router 7 right now?
Yeah.
There's no learned routes via OSPF yet.
Yeah.
But on router on God.
Yeah. Go ahead.
So we see we've got a full neighbor. So let's go figure out why. Of course, we may have just advertised our own routes in here.
Yeah. See.
Okay, here we go. Now look at that routing table. Okay, we've got some C for connected routes. We've got something with an O next to it. And it's because it says an O, we know that it's inside of our area. If it was from another OSPF area, for people that are not used to OSPF, what we do is we divide into areas to segment our network. We have this area 0, which is the concept of a backbone. This is where we put our highest performance routers. See, what goes on is everybody inside of this area will know about every single link inside of this area, and then we'll run what's called an SPF calculation on it. That gets computationally expensive. It really runs up the use of the CPUs. So from an architecture perspective, you kind of decouple things, you modularize things. Guess what? All those decoupling and queuing things and microservices and all that stuff you're hearing about now, this is 30-year-old networking for people like Imran and I. What did we do? We took a network, we ran OSPF, a link state routing protocol. And guess what? There were too many computations in our network, so we decoupled it and we segmented it. So we created the concept of areas. The OSPF area 0, the backbone, knows everybody's everything. It knows all of our stuff, and we get summary information from external other areas, and they're propagated very differently. So by segmenting our areas, we can do things like create stub areas or totally stub areas or massive stub areas. We can reduce the size of the database. So you want to show what the OSPF, show IP OSPF database or LSA database or whatever it is. Okay, so here's what you see. You can see the series of links that you received, and you can see where you learned the links, and you can see the age in seconds. So you got a sequence number, which is a message number. You got a checksum. What is a checksum? Basically, it's a one-way mathematical hash to determine that your data is good. So I just wanted you guys to see this is what goes on in between databases. So go back to that routing table if you don't mind. And Shapur, welcome. Zaki, welcome. Jeannie, welcome. More networking. Yeah, let us know in the networking window that you're having fun with networking. While Emma's busy configuring this and explaining it along the way.
So,
okay, so look at this. This is what you're going to see in a rail routing table. Connected routes, OSPF learn routes, BGP learn routes, static learn routes. Now going back, let's look at this. This route is learned via BGP. It's 2.0.0/8. Note, its administrative distance is 20. Note, this next route is learned via OSPF 7.0.0/8. Its administrative distance is 110. Guess what? If we had a route learned from EBGP to 2.0.0/8, and we had a route learned via OSPF of 2.0.0/8, which one do you guys think is going to be believable? The one with the administrative distance or believability factor of 20, or the OSPF one where the believability factor is 110 due to the administrative distance? Note, the lower the administrative distance, the more believable the router is. So which do you think is more reliable? An OSPF learn route for a subnet with an admin distance of 20, or an EBGP learn route with an administrative distance of 20, or an OSPF learn route with an administrative distance of 110? Pop the answer into the comments section.
okay.
See, Imran's getting a little fancy here. See, when I started, we just did a show running config. We'd look at the configuration. Now with the newer versions, we can pipe and grab and do all kinds of cool Linux stuff. And that's what he's taking advantage of here.
See on R1, we are receiving the OSPF route. We are not redistributing it, because the way to redistribute an R1, the way to redistribute R1 or OSPF, there are two ways to do it. Either we redistribute it, or either we advertise a network statement. So first we do the network statement, then I will show you the difference of those routes, and then we will remove it, those routes from the network statement, because let me put advertised by a network statement. So I'm advertising the 7 network and 77 network by using the network statement and a BGP and R1.
Okay, so we've got R1, we've got our neighbor adjacencies up, right? Yeah. We've got BGP configured. R1, do we see all the routes we need to? from our data center, and
Yeah.
does the data center now see all the routes from, what do you call it? From the cloud?
Yeah, yeah. So
Okay, good. Have we configured routing to the internet service provider next?
yeah. So if you see like show IP, do show BGP. When you see on a BGP table, these routes will be coming as an I, and you're seeing an I here, the I here, I here. I means is preferred over the EBGP. EBGP like question mark. So I always prefer the EBGP because the reason is we put this on as a network statement. That's what is showing that. So now the other way to do it, of course, you have 100 routes. This is just like a 2 routes. You advertise it by using the network statement, but you have 100 routes coming in. You will not do this away. So you redistributed the whole OSPF domain. Then you control the policies, what route you want to see. So I will remove this. Just want to show that.
Thank you for demonstrating that. That was really good.
Yeah, so I'll go short. So I'll remove this from the R1. I'll go to the router BGP 100. And I'll remove this. So how do we remove the network statement? No command and add it to the whatever the routes I just added. We are learning from our routing protocol. We are going to remove it and show you how to redistribute the other way, the better way. Just to understand the concept of network spectrum and redistribute things.
It's pretty amazing that the no just reverses everything. Best way to remove it.
Yeah. So if you go show IPBGP, you're not seeing those routes, 7 and 77. Okay. Now you're going to redistribute this. I'm on the routing protocol BGP domain, and I'm going to redistribute OSPF everything. Is OSPF 1.
Okay, so what he's doing here now is he's taking the information learned via OSPF and then placing it into BGP so BGP can share it to other people. That's called route redistribution. Note, he could put a network statement. He could have, redistributed connected. He could redistribute OSPF subnets, and then and that's how you could do this. So that's kind of the information, because we've got to get our information into BGP to then push the information to someone else via BGP.
So if you see the reason I do this, because when you learn the routes over there, so it's now you're seeing the question mark. You see that the question mark is incomplete, right? Or
incomplete routing information, yes.
Correct. So if
you want to talk about the origin code over and how which is preferred?
Yeah, exactly. That's what I'm trying. I want to show them how do we change this. So you're learning the routes from question mark, and earlier, if you see on the top, you're learning the routes by I with the origin code. So I always prefer the question mark. Want to add something here?
No, I think it's great. You're talking about the origin code. You're showing how to change it. I'm thrilled.
Yeah. So I'll put in an out map and change it to I, and there's a way to do it. So that's what you're controlling route. So I'm on R1. Okay, route map.
And apologies for some people as Imran's doing this, I'm typing commands back. I have been a martial artist and Olympic weightlifter for many decades. And let me tell, not these days after I shattered a hand and foot, I'm training, but I will tell you, we've got lots of arthritis. So my typing's not so pretty. So if I type quickly to try and respond to folks on this call, apologies for the bad spelling.
So
Arthritic hands aren't too clean.
100. So we are redistributing, but we are redistributing with a route map right now.
And by doing this, by redistributing with the route map, he can change the origin code to make something more preferable, for example.
Correct.
You want to explain how, the preferred is, generated in one way versus another way?
1 second.
There you go.
So
the route map, he can name it anything he wants. And here he's basically doing something that's going to match something else and just change the origin code. And when we're done this, we'll demonstrate you by walking through the routing tables from end to end. And guess what? We might use a route map to filter something or use a community or something like this. We'll get to have a little bit of fun with the BGP attributes. Networking's cool. At least for me, it's always fun to watch the way these things work. So now he's got his BGP configuration. You can see he's connected to the external neighbor and remote AS 200. You can see he set up EGP multi-hop because he's going loopback to loopback, not exactly directly connected. And he's told it to update from the loopback. So now you can see what's going on here. Now as you look, it'll no longer show incomplete. You wanted to show the IBGP table?
yeah, for some reason it's not turning. It's not.
If we clear the BGP neighbor. Sometimes this should never happen, but sometimes what's going on is when you're connecting to people in BGP and you modify something, some data gets corrupted and you've got to basically reestablish the session, kind of like your cache that gets corrupted. I'm not sure that's what's going over here, but we should test it.
Let me review this one more
Give it
time.
a minute to kind of come in. We set the origin code, but did we match anything? I didn't see any matches in the route lock. I didn't see like a match in access list. I didn't see a match.
I think maybe the names are incorrect. So let me put the.
And this is why you build your configurations, generally speaking, ahead of time, because this kind of will happen.
Yeah. Let me remove this route map. One second.
We need to match something, either matching the IP address of the interface, create an access list, match the loopback.
Yeah. 1 second. But it should change to preferred. So anyway, we'll continue. Just redistribute the BGP. Yeah, it's coming in. See, the route map name is incorrect, so that's why it's not catching it.
Well, you know,
The type of, yeah.
typos will get us every single time.
Yeah, now you're seeing as you change it to redistribute. Now you have an OSPF route with the I origin port. Earlier you're seeing a incomplete thing. So does that make sense now, Mike?
Completely. So you can see where the routes are actually coming from. So now, which you're on router 1. So going back to the topology, you know, we see if you go back to the show IP route on router 1, just so we can go back, walk through what we see.
Show IP route.
Okay, so let's look at that whole routing table. Okay, so here's what we want to see. We want to see who's learning what from where. So we're learning the 7-knot subnet from OSPF inside of our area. The EBGP, we're learning, which means it's coming from our personal data center. We're learning the 2.0.0/8 via EBGP. We're also learning via EBGP, the 22.0.0/24.
I'm sorry.
So for all those Slack messages coming into Imran's desktop, the reason when we talk about being a network architect or a cloud architect, being really brief and to the point, you can see messages directed to me or popping in on Imran's laptop for people submitting homework assignments, which I love to grade. So, because that means my students are learning. So just realize when you speak to executives, the reason they have such a short attention span is that thing that's going to Imran's desktop that's related to me doing things. That's just one of the many millions of email messages I get during the day. It's not millions, but it's a large number. So realize executives are that way. That's when you hit an executive fast to the point before they change their mind and their mind goes and drifts to someplace else. So good routing table, we get to see this. Note, there is no default route. So if we don't have a route to somewhere else, we are just going to drop the packet. And that's the way it should be. We don't need a default route right now because we're running BGP and OSPF for everywhere. So perfect. Now, we have our data center. Do we have BGP up and running in our data center, or do we have just EBGP, or do we set up IBGP and OSPF?
We'll set up my BGP as well, Mike. Between R2 and R3, we'll set up a IBGP, and we'll have a we have one on like R2. We'll have a set up a loopback. And we set it up like here we set it up a OSPF, where we set it up a EIGRP between the reachability perspective, the one I set it up, and let's see how that goes with IBGP.
Excellent. So why don't we do this? Can we come to router 2 and show what we're learning from router 1, and then hop on over to router 3 and show all the stuff that we don't know yet without IBGP before we move over to things?
Right.
And of course, while we do this, if any of you guys have any questions or any desires to ask or learn something, tell us. If you guys want to learn something, if it's possible, I'll make content and generate it for you. So tell us. We really, really want to do what we can to help out. Okay, looking at this, look at the show IPBGP. Look what we've learned. We've learned about the 2 network, meaning it's originally generated by us. The 7.1, we learned about it from the next top, you can see it. The 77, we learned about it. And the network, can you do a show IP route 2 so we can actually look at the entire routing table? Okay, so note we've got some B's and C's. What do we not have yet? We have no OSPF learn route from our internal network. And if he goes now from router 2 to the router on the top of that triangle in our cloud, please note what routes actually are going to exist in there. Imran, can you show that routing table?
From where to where, Mike? Sorry.
So Okay,
This is
so
R2. This is R2.
I need to see the picture to know which one.
Yeah.
If you can just slide the configuration down so I can see the topology real quick.
This is R2 where we are.
Okay.
So we
If
need
you can
to
go to
build.
R3 or R4 and show that none of the, for example, none of the routes via BGP are learned there because there's no IBGP. Oh, you have IBGP running?
This is R3.
Okay. So the BGP configuration here. Okay, so, okay, the routes that are being learned from this guy are being learned from the internet service provider at the top.
Correct.
No, there are no routes learned from R1 here then.
No.
So the routing information on R1 is not the same routing information that's on R3.
Correct. We're not learning anything from the OSPF here.
Okay, so let's stop for a couple of seconds before we do. There's a couple of questions from the audience I want to address. Someone doesn't understand what a route map works. Okay, let's be fair. The route map is kind of Cisco certified internet expert level work. What a route map is as follows. If I want to take in a route from something, let's say Imran and I are EBGP neighbors. I'm communicating with Imran. BGP could send me something called, Imran could send me basically a community, call it community red. I could then take in community red, and community red is arbitrary. It means nothing to me. But I could then take in community red and say, match community red, increase the weight, which we prefer, increase the local preference, lower the med. So the route map is really some advanced Cisco router configuration that enables you to take something and do something else with it. The route map works almost like the code, the programming language basic. So Imran says me, let's say he sends me community red. I could say, match community red and increase the weight of this subnet. So I hope that kind of made sense. A route map is just a means to tune something. Basingi, we will have another session for follow-up, and you can ask any questions you want anytime. To be fair, Basingi, this is real network training. We have gone in the beginning to CCNA level, then we've completely exceeded CCNP level, and we're kind of hovering here in that CCNP, CCIE level. I got to tell you, if you want to be a cloud architect on the network, you got to know this kind of information. So this is kind of the basic networking, and this is heavy duty networking. Yeah. This is serious networking, because when I say, if you want to be a cloud architect, learn the network in the data center, this is the network, and you got to understand this. And when you go to the cloud and they talk about BGP, or they start talking about Cloud Hub or Transit Gateway, you're going to see that this is all just this stuff. So don't worry. I spent 20 some years studying this. Imran spent 20 some years studying and mastering this. I don't expect it to all be there initially. You can watch this video multiple times. We did a completely free AWS Advanced Networking, which is kind of like an intro to networking. The link is in the description below, but my associate Chris will pop that there. And don't worry, you will learn it. Step by step by step by step. We'll break it down into what you need. We're going to do this again and again and again. And don't worry, we'll get you there. Here's the thing, Basingi. First, you need IP connectivity. What is connectivity? Basically, you need an IP address and you need a link. And that's connectivity. Then you need a path to the destination. How do you get a path to the destination? You either put static routes everywhere, or you run a routing protocol. That's what we're doing today. We're working in routing protocols. Please understand, it has taken me year after year after year to learn these routing protocols. So yes, kind of look at it. Imran has spent years mastering these routing protocols. I spent 10,000 hours on just BGP. So when you see people that's teaching a networking course, like if there's somebody, a certification provider making a networking course that's never worked in networking in their life, and they advertise their advanced networking course every day, realize this is just intro to networking. And even here, we're getting in this CCNP, CCIE area. So If we have to do this a few times, that's great. If we have to educate the providers that are making courses out there about networking, we're happy to do that too. All we care is about the cloud community.
So just to add here, the reason we took the BGP because we want to map this cloud networking piece into real networking. We need to learn the BGP very well. So most of the routing protocols in the cloud side, you're having a pairing of a single connection, dual connection, and how you manipulate the BGP routes with different use cases. So this is just a simulation, and we have more to come, and we can start. If this is too difficult, we can have a start from basic to a higher end, but this is really a complex scenario. We just want to show you how the routing works, the concept wise, and of course, how you manipulate routes by using different BGP is there for last more than 20 years. So as Mike said, there is change. Everything is in the cloud, but the routing protocol is the same and the same behavior. So we are just simulating different clouds here, data center, and different AS, and you can manipulate. You can return this topology for anything else. Mike?
So I was looking at Peter's question. Peter, I hope I was able to answer your question about the route map. The route map is this. I have information. I'm going to take that information, match it, and then do something with it. So I could create 1,000,001 route maps. A route map could be, if information comes in on my left arm, send it out my right arm. Or a route map can be, match this, do something. So really all the route map is just matching something. And we probably went a little too deep with the route map really first. But realistically seeing, we'll show that. We're going to build the basic nature without the route map first, get all the routing up, and then we'll do this stuff. The route map is a tuning factor.
Route map is just an access list controlling your routes, what need to be there. Basically, that we call it traffic engineering, what need to be inserted, what needs to be going for this specific attribute for BGP, or it can be anything. You want to allow any specific network, and you want to allow deny any specific network. So we're controlling the traffic. The route map is a tool. You can use it in any other routing protocol. So what I do now, between R2 and R3, I create a loopback, and I create because we have a OSPF here, we will use an EIGRP here and see how things work in EIGRP, and then we see the reachability between by using the loopback. So I'm on R2. Let me go to R2.
Excellent. So
I'm creating an R2 as a loopback.
Sounds good. We're gonna set all this up, get everything up and running.
An R3.
And Peter Hunt, basically, exactly. If you match something, take an action on it. That's exactly what a route map is. Excellent, excellent. Sorry, Imran, while you were doing such a great job with the networking, I was trying to make sure I addressed some questions.
I just create a loopback 10 on R3 and R2, and we run EIGRP between R2 and R3. And what we advertise this network, this connected network, 192.168.23 network, and of course we'll advertise this network as well. So I'm on R2. So on IGP, Mike, we are having two networks we are advertising directly connected. This one and this one, and this one and this one. And we are configuring EIGRP. So
Okay, so note the loopback is up.
Yeah, so
You're running EIGRP inside of this autonomous system?
I will. That's you see the
okay.
command?
So for fun, we've chosen to use another routing protocol as our IGP in our internal area. Let's face it, lots of organizations use EIGRP because it's very simple to maintain. Lots of organizations use OSPF. Big service providers use intermediate systems to intermediate systems as another type of link state routing protocol. So what Imran's going to show you prior to setting up the IBGP is when he configures these 3 routers in our area, note, they're all going to have different routes. They're all going to learn each other's routes for these 3 routers. Did you set up EIGRP on all 3?
No, I'm just setting it up. I just want to show the audience. This is the commands I'm pasting it. Router EIGRP 200. This is the network on the one side, 23 and 24. And this, as I said, when you use the network command in IGP protocol, these are the network locally connected. So, and I'm advertising, you see on the, just paste it over there. So if you see the R2, that's 23 and 24 network, and this is like directly connected interface, and of course the loopback 10 which I created. So all these are directly connected network, and I'm reaching this by putting this on an EIGRP. Mike, you're good?
I am totally good.
So I'll do the same thing, router EIGRP 200 and 34, 23, and 34. Paste it. See, you can see the EIGRP neighbors are up. Between R3, R2, and I'm going to go to R4. So,
and Mohammed, exactly, you got it. Just if this, match this. So Imran is going to set this up. For those that are on the call, if you could leave a like or share this message or invite someone if you find that you're getting some good training. We always like to share our content with as many people as possible.
So I create a loopback 10 and create a EIGRP on R4 as well.
Yes, so we don't really use any reserve addresses here. I'm not really sure what you mean that. When you're dealing with networking outside of the cloud, basically the subnet address is reserved because you can't use it. It's used by the router for the route and the network, and you can't use the broadcast, but otherwise all addresses are good. On the cloud, it's a little different, like the first 5 addresses of the subnet or 4 addresses of the subnet are reserved for experimental purposes and such, and then the last one is the broadcast. So it's a little different here. Okay, so look what's going on here. So
if I'm on R2, when I do show IP EIGRP neighbor, you're seeing I'm learning, I have 2 neighbors.
Okay, so looking at this right now, router 2, he's got 2 neighbors. So he's learning EIGRP.
Yeah.
He's learning EIGRP routes from 2 neighbors. So regarding auto summary, well, there used to be this concept in EIGRP where it would naturally just summarize routes to classful borders, which was an awful nightmare for all of us. So we all typed no auto dash summary. It's probably, we're using iOS version 15 dot something. Do we have to disable no auto dash summary in this, or is it disabled by default?
Okay. So if you want to verify, of course, we have 2 neighbors here, and R4 and C. So now, as I said, we have a reachability in R2. So can we ping the R3 loopback address?
So what he's going to now do is test the networking to make sure he can see it.
See, I can see the loopback for R3.
So he sent 5 ICMP echo packets and he got 5 ICMP echo replies back. So now look at this. Okay, what do you see in the routing table? You see you're directly connected. You see routes that you're learning from BGP, and you see these routes that have a D next to them. The D is coming from EIGRP, internally learned routes. Note he's got two equal cost links. And because he has two equal cost links, you can see them as 90 / the actual link cost.
Can go from here, can go from there.
So Andre asked a great question. Is there a great way to learn the configuration language? Well, let's put it into concept. When you know what you want to do, it's easy to look up the commands. On the CCIE exam, they basically ask you to design something that's super complicated. Imran's done this with 2 CCIEs. He's doing the third one just to prove his son, hey, by the way, I can do it, which makes him my hero. I've done mine back 1,000,001 years ago, and it was this miserable 2-day test, and loved it, but it was fun. And they would literally hand you the CD with all the configuration commands. They just wanted to know if you know how to do it. So learning these commands, typically speaking, many of these commands are learned at the CCNA level. The rest of the commands are really learned at the CCNP level. Cisco and their website has all the free configuration training you need. Knowledge of knowing what to do and how to design and how to build, that's what we're doing today. That's not free. That comes with training. So configuration commands, always easy to do. CLI is easy when you know what you're trying to do. So just by working on this, you learn it.
Okay, so now we have this working. We have a reachability for the loopback here by IGP. So now, as we said, we have to configure IBGP because whatever with the route we learned from AS100, it's need to reach on the both edges. Mike, that's very important. Yeah.
So perfect. So
yeah, whatever we learned from this is the AS100 or AS600 just need to reach from here to the exit of the edge with the right property. So that's why we use IBGP, which is having a support function for EBGP. I just want to reemphasize the core.
Perfect. Function. So I want to make this clear. Without IBGP running here, show that there are different routing tables on R2 and R4. Can you show that? Show the full routing table here.
Yeah.
I want everybody to really see this. Okay, so this is you're on router 2. You're getting some BGP learned routes from the top internet service provider.
Correct.
And you're getting some EIGRP routes from the community, but you've not configured IBGP right.
No,
right? Because I was answering questions. So note, on router 2, you're not going to get any routes from AS100 where the cloud is yet. You won't have them on this router because, realistically speaking, you haven't learned them yet. So we're going to need to run IBGP across our network in order to get these routes. We're going to try and avoid things like redistributing OSPF and EIGRP. Look, they make you do it on a CCIE exam. There are times when you need to do it, but no matter how you do this, no matter how you set up your prefix list and distribute list, this is ripe for actually causing routing loops. But running IBGP across your backbone will pull it all in and enable you to connect it to other autonomous systems. So what's going to happen is Imran's going to actually set that up. Now he's going to show you the routes on router 3.
See, you're not here, so you're not learning anything, any BGP routes here.
Good. So you want to show the IP routing table from this one? Okay. So we're learning 2 routes from BGP. A little bit. Note we have a lot less routes in the routing table on this one. Why? We're not pulling them in from the cloud provider. So what do we got to do to make that work, Imran? How are you going to make those cloud provider routes be available to all the other devices in our system?
Yeah, so we need to have IBGP working, and between these two and these two and these two. So it's like at this moment we just have IBGP. We have a reachability, and now we will configure an R2, R3 as an IBGP protocol. With of course slightly difference with the neighboring command and upload source loopback and the next hop as well. So
let's set up that IBGP.
Yeah.
And when we have this network configured and it's fully finished, we're going to get to have the fun. We'll do some trace routes. We'll start manipulating traffic engineering policies, but we've got to build it. So this is the infrastructure fun time. If you get it, type network in the chat box. I know you're not sleeping. Please let me know by typing in network or network.
Okay, so I'm configuring IBGP on R2.
Okay, so now he's going to set up the IBGP. So as he does this, let's note what he's actually doing when he shows you the configuration.
So if you see the config here, so I'm putting as a router BGP as my local AS, and I'm neighboring with 10.3.3, which is a remote on the top, R5. And this is the loopback what we created. So we are doing a neighbor relationship for IBGP as a loopback, and we check the 10.3.3 have a reachability, and we're putting in a next update source will be the loopback 10. And further, it's a very important command. We are adding this next hop self command. We are telling the neighbor next hop self, and how do I describe the next hop self? It's very important.
Okay, so here's what's going to happen. If the next hop is not reachable, the route will be in the BGP table, but it won't be in the routing table, so you can't reach it. So what's going on, because we're using loopbacks and we're not actually using that physical link where you would just be on the link, we kind of have to give it the next hop, which is ourself. And because if the next hop route isn't on our routing table, we need to make it sort of there somehow, or else the route won't be placed in the routing table. So that's what he's doing. Note with the neighbor statement, the remote AS is the, oops, didn't mean to do that with my Mac screen, but the remote AS is the same number as our autonomous system, and that's why it's IBGP. Note, if that remote AS was 300, not 200, it would be a different organization. So when you connect to the cloud, it's always going to be a different number than you, but when you connect to you, it's going to be you.
Same thing. R2 and R3, they are on the same AS. So you can notice R2 BGP. See now.
Okay, there you go.
Yeah.
Now in router 3, you want to show everybody where router 3 is on the map?
So router 3. That's router 3.
Okay, so look, actually, can we slide that thing down a little more so people, okay. So look at what router 3 is. Router 3 is now, at the top of our AS200, that's our data center. So this is our data center. Now on router 3, if he's going to do a show IP route, we should be able to see routes from router 7 sitting in the cloud. And we should also be able to see routes that are coming from AS500 because we have EBGP pairing there. So on router 3, we should have a lot more routes than we had before. So let's see what we got there, Imran.
R1? Sorry?
On route 3, show the full routing table. It's going to be a big routing table now.
Okay. So now you're seeing this is coming from BGP routes here.
No, now look at this. Now look at these routes. So we're going to see all kinds of things. We can see, for example, that we learned certain subnets via IBGP. Note that 200, that's administrative distance. So if we have 2 routes in the routing table for BGP, or we have 2 possible routes, we got a 2.0.0/8 with EBGP, and we were going to learn the 2.0.0/8 via EIGRP. EIGRP is administrative distance is 90. BGP's administrative distance for IBGP is 200. we would put the other one in the routing table. Now look at the routes we learned via IBGP. Note, they have that administrative distance of 200. By comparison, let's look at the route to the 5.0.0/8 subnet. Note, we're learning that via EBGP to our upstream neighbor. So different administrative distance, different believable. But what I want you to see here is now the routing information that we're learning from that ISP up top, we have inside of our systems, and all the information we got to the cloud, we're still maintaining on our system. So we've got a lot of stuff going on right now. Of course, MRAM saving the configuration with the right mem. And before you get to the next router, I'm going to ask sir a very good question from Mr. Andre. He says, in real life, what are the steps? Design, configuration, customer. The configuration steps, the system, the way it starts for the architect is as follows, Mr. Andre. Start with the customer. Ask the customer, what are their business goals? What are their business challenges? What are their pain points? Then the job of the architect is to go back and think, how do I enable the customer's business to work properly? That means, what kind of solution can I design? So as the architect, we design that solution. Now, after we design that solution, somebody's got to go build it. So we turn it, as architects, we're kind of done. We turn it over to an engineering team to go build it. And then when the engineering team's done build it, they turn it to an operations team to go maintain it. So, Mr. Andre, I hope I answered your question. This is the role of the cloud architect or the network architect. It's the same thing. Meet with clients, figure out requirements, design, and then turn it over to engineers to go build it. So that's kind of what the steps are. Imran, I'm sorry, back to you.
Oh, that's fine. That's fine. So we have a IBGP relationship built up between R2 and R3, and now we need to configure between R4 and R3, which is, if you're saying R4 and R3, that is the part. So.
And when you go through these, if you could just remind people each time where the routers are on the map, because it's hard to remember all these routers.
Yeah, so this is R4, and this is router's R4, and we configure this IBGP here, and the same thing between our R4 and our R3 basically. And
okay, so you're gonna set up router 3. You can see where it is. Note, when this is here, he's going to be picking up routes via IBGP. Then at some point, he's going to connect it to that second cloud. We'll call it Azure. So once we get all of our routing up and running, that's when the fun begins. That's when we can start tuning, we can start teaching, we can walk you through, but we hope we're trying to make it a good examples of what we're doing while we're building. We hope you kind of get the feel for this. We understand this is very complicated technology. This may not be possible on the first time. We produced a link to an AWS Advanced Networking content. It's kind of like AWS Advanced Networking is kind of like an intro to networking course. And because of that, we made a completely free course. Chris from my team posted a link to it. It is on our YouTube channel. But this is much deeper. This is the kind of work an infrastructure architect would be thinking about, or even a good cloud architect for that matter.
So on R4, we're having a router BGP, and we are routing by 10.3.3. That's a loopback for R3. And we're pasting it here. And R3, we do the same thing. So if you go to the R4, so I think R4. That's this one.
Nice.
So if you notice here, we are learning the 77 network AS200, and AS100. You see the AS200 is here. I'm on R5, which is AS500. So I'm showing you the network. Sorry.
Okay, so now what you just see on R5, unless we run any filtering, and we're going to have some filtering at some point, what you'll notice is we're going to have routes learned from the data center and the cloud, and our data center and our cloud. So on R5, it does a show IP route. No, you're learning all those subnets via EBGP. So that means they're reachable.
Correct.
And for those people that are not familiar with BGP, Chris from my team will do the following. We've created several videos on BGP that are sitting here. They're the ones, Chris, that begin with like intro to networking, and they have AWS BGP with a pipe spaced in between them. If you can link these, Chris, if you can put a link to the BGP document that we wrote, which explained all the BGP attributes and how to manipulate them, how to optimize them, please place them to Chris into this window.
So the thing is, we're trying to show you like is having a right the right AS, because even though it's coming from IGP, it's coming to the right AS, it's coming from 100 and 200. That's the reason. That's the reason we show you how to redistribute it. And the reason is IBGP again is helping EBGP to change. Do not change this attribute. If this attribute does not change, and you're seeing is taking the right AS path to avoiding any loop avoidance. So.
Okay, so I really, I want to just try and take that and run with it for a minute. No, this route 77, it's AS path. Remember when I talked about in these videos, one of the things you can do, prefer the path with the highest weight, prefer the path with the highest local preference, prefer the shortest AS path. If you've got more hops over in here, it's going to be a longer AS path. So later we're going to have some fun by tuning AS paths. But for now, I just wanted to elaborate, as describe the path that the autonomous systems your data is going to travel through to reach its destination.
Okay, what is R7? R7 yeah, that's 77.
Okay, well, when we see this, what do we know? We know we have one of two problems. We either don't have a route to it. Do we have a route to this in the routing table? And if the answer is yes, the next problem is they probably don't have a route back to us. But we can verify this and we can see where the traffic gets lost with the trace route. But the BGP may not have that chance to converge either.
Yeah. So let's continue. We can troubleshoot later, but as long as we understand the concept, it will be very valid. So now I think the last part I have is Mike. Before we end up with this lab thing, is configuring is R3 as RR.
Before we do the route reflectors, did we get all the BGP running to all external autonomous systems?
Yeah, everything is configured, I believe.
Let's just check, verify everything, and then we're going to start having some fun.
Yeah, so it's R5. I'm learning 2, 3, 5, 2, 3, and 5. 2, 3, and 5. Number 5. So 1 second.
I know there's some complexity with some of this stuff, but nothing worthwhile in life is ever super easy. And I can tell you with persistence, perseverance, and a little bit of work, you can learn this network, which will put you leaps and leaps and leaps and bounds above everybody else in the cloud architect world. And if you're trying to get your first cloud architect job or get promoted as a cloud architect or take on bigger roles, realistically speaking, this is something good for you to know. Now, Chintan, don't you need routing between 2 and 4? I actually have to see the picture to even remember where is 2 and 4.
2 and 4, yeah, 2 and 4.
Without the picture, I lose the map. But with 2 and 4, I'm assuming we have to have routing between them.
Yeah, 2 and 4. The network is directly connected to 24, and you can see you have 24. Yeah, that's.
You know what? While we're here, okay, yeah, the routing's fully configured.
Yeah.
While we're here, you know, as architects, sometimes you meet with a client and you ask them what they've got, and occasionally they don't know. Now, pretty scary, but occasionally someone just doesn't know what their network does. So people like Imran and I have literally mapped out networks by going from router to router to router by doing something called show CDP neighbors. So if you want to show what that shows, we can actually find who our routers are next to us through this layer protocol called CDP. What's the Cisco Discovery Protocol?
Yes, Mike, just need a 1 second break. Just keep continuing.
Sure. Okay, we'll come back to me. I'll start asking answering some networking questions for a little while. I am always fun and happy to answer some networking questions. So while we wait for Imran to come back and start doing some configuration stuff, do we have any networking questions so far? IP addresses, routing protocols, subnetting, anything we need to cover while we're waiting for Imran to come back? And in the meantime, people can type cloud architect. So I know you're there. That's great. And if you're having fun, if you can leave a like or a subscribe, please do so, because that signals the algorithm to then share our content with more other people. And we want to produce as much free and highly valuable content for the cloud community all over the world. We realize that not everybody can afford our training, and we want to make sure for those who can't, we still provide ample quality training. So if you need to if you guys have any questions, please let me know. So while we deal with a few things, you know, internet connectivity things, does anybody have a question for me? Because we got a couple more minutes and then we'll go back to Imran. Any questions on the network? Any questions on routing protocols? Alonzo, you're having fun with networking. That is fantastic. Reginald, Cloud Architect, let me know. You guys are here by typing Cloud Architect. Leo asked a very good question. What is the advantage of using EIGRP instead of OSPF? I got to tell you, 100 years ago, when I started networking, or I should say 25 years ago, EIGRP was used very frequently because it was very simple to configure. OSPF was a CPU computationally expensive protocol. EIGRP was light. So organizations used EIGRP because it was simple and elegant and a little more tunable. In today's world, for the most part, I don't know many people that actually use EIGRP. For the most part, what I typically do is focus on OSPF, typically speaking, and BGP. EIGRP, I don't know in your experience, Imran, if you're still using it a lot, but I stopped using it about a decade ago.
Yeah, I think, thanks, Mike. There are customers still using EIGRP. Some of their flat networks, just to add here, EIGRP is a Cisco proprietary, and OSPF is, of course, open standard. There are certain customer use case, small flat networks, people love it, very easy to manage. So it depends on the scale, size of the network. Customers still use it and they love it and they keep using it. Depends how scale and larger networks. Now, typically, the larger network, the OSPF and ISIS, and of course, from the cloud era, mostly in the BGP, yes.
Absolutely. So next question from Mohammed, with real data centers, You will define a routing protocol, absolutely. Typically speaking, in a data center, you're going to use OSPF all in a single area because it's in a, but and usually you may have to constrain it, but typically it's OSPF in a single area. Inside of that single area OSPF, everybody will know everything about everybody else's routes, and you'll have very fast routing. Now, outside of your data center, when you connect to the internet, you are going to be using EBGP to put that into context. But inside of your data center, everybody will be using an IGP like this. So Basingi, just to recap from the presentation, what is AS 100, 200, 500, and 600? They are different companies and different organizations. So one of the organizations in our specific environment is our data center. One of the information up top, I believe that's AS 500, is an internet service provider. On the left side of this document, we've got an AWS VPC, and we're running EBGP to it. And on the right side of this document, we have an Azure-based VPC, and we're running to it. So I hope I answered that question for you. So going back to Imran, because now he's back to a position where he can go back and configure things. And actually, at the same, before one more second, Derek Houston, one of our wonderful, super capable students, said telecom companies, they actually did have routing tables for routing their calls. And routing and phone things basically had a dial plan, which was a lot like a routing table that determined the route calls from one call to another. And you know what? Then there were these competitive local exchange characters that took over the big players, and then it all went voice over IP anyway. So, or at least a lot of it. So that's kind of the thing. And definitely, Derek, you're there. Imran, back to you. Imran, you're speaking to a mute, I think. Could be wrong. 1 second.
Yeah. So just to add here, as Mike says, this is like a data center. This will be like AS500 will be your cloud provider. AWS can be another company. The reason we show to you, it can be any use case. It might be a GCP, it might be Azure. So basically, you are interconnecting with different AS, different companies, different organizations. Maybe within your organization, there's a separate network. So, and maybe on the left-hand side, you're having multiple connections with data centers. The reason we show you different use cases, just try to simulate the network piece as long as the cloud concept is, how the routing works, how you manipulate IBGP, BGP, who is doing what are the RR route reflectors. I think that's the last step I have, Mike, on my
Perfect.
configuration perspective, where we'll make R3 as a RR. The RR is just like you configure RR just like your transit, and when you don't want to have a mesh connectivity, the RR will be used. It's like a hub and a spoke kind of a scenario.
Okay, so let's play with that route reflector concept a little bit more. So IBGP is non-transitive, meaning if I take a route from Imran, I won't give it to my wife, Lisa. And therefore, Imran can't communicate with Lisa through me. Great, right? But what if I want Imran to communicate through me? I either have to fully mesh my IBGP peers, which puts us into this scalability problem. The number of IBGP peering sessions you're going to need is going to follow this formula. N times N minus 1 divided by 2. So 100 IBGP peers, 100 times 100 minus 1 is 99. So 99 times 100 divided by 2. Can you see exactly how that will not scale very fast? It will become a mathematical nightmare. So with AWS, you have Cloud Hub, basically taking your routes, passing to somebody else, transitive routing. Where did Cloud Hub come from? What have we done 30 years ago? We had a route reflector. What is a route reflector? It says, do not follow the rules of non-transitive routing. Now I learn a route from Imran on my autonomous system. I pass it to my wife, Lisa. Now Imran and Lisa can talk to each other. So that's what a route reflector is.
Perfect, perfect. So I think our last step of the configuration, so I can wrap up at least my intent.
Perfect. And then we're going to start playing with it and tuning it and really exploring the traffic flows. My fun time.
So on R3, I'll configure as a route reflector. So So on R3, I'm telling this is the basic config you need it. I'm telling the neighbors 10.2.2, router 2 and router 4. You are my router client, basically. Now you're seeing the things are coming up. Yeah. The neighbor was not up earlier, so because we're in.
Now we definitely see the neighbor. So what happens? They form an adjacency. You get a syslog message, and then you start noticing things. The neighbors are up. And now we're going to have some cool routing. Sorry, you have to excuse my enthusiasm. I've been playing with routers and switches for 25 plus years, almost 30 years, and they're just fun for me. I'm like a little kid with my propeller hat once we get a network router or switch out.
Okay.
Now is making sure the next hops are reachable by making them the self.
Let's see if I can.
And once we get all this routing configured, we're going to check, make sure it's up. Then what we're going to do is we're going to trace the path of the traffic through the network. Then once we trace the paths, we're going to show you how we can tune those paths, step one at a time. You guys having fun building a network in real time? If you're having fun, type network fun in the chat box. I'm having fun.
Something is broken here. Yeah.
You were missing a route or a route back.
Yeah.
So let's figure out where we lost it. Leo, network fun. Nick Love, network fun. Reginald, network fun and good. Theo Q, network fun. Jam, you got it. Peter Hunt, you're just starting, and that's okay. We'll get you there. Network fun from Derek Houston. Awesome. Amaranth, I know I wanted to get you learning some networking, Amaranth, and awesome. Chris Johnson, welcome. Alonzo, bad storms. If you lose your power, I understand. I live just outside of Palm Beach, Florida, and let me tell you, I have a network storm of the day. I have 4 UPSs running in my house. One for my network gear, one for my server room, one for my Mac and all my monitors, and I've got another one running too. So network fun, guys love it. You know, I made some intro to BGP videos. Would you guys like for me to do like a 1-hour intro to BGP video coming up in the future? And then, for example, have a network expert demonstrate all these things. Is that a desire? If so, let me know. Intro to BGP in that chat window. Now I'm going to go back to Imran now because he's been doing some debugging and things. You good, Imran, or you need a few more minutes?
Yeah, no, I'm good. I think we need to restart something here. I need to step away as well for something urgent. Mike, can we wrap it up here, or
okay?
Do you want to continue?
Ideally, I'd like to actually show this through the traffic engineering, but if you have something different going on, I understand completely.
I got a bombardment of telephone calls. I just want to step out at that time. Yeah.
Okay. Well, we will do as much as we possibly can, Imran. And if things change, what we'll do is we'll have another session coming up soon.
Absolutely. We haven't just finished the basic setup and basic routing setup, and just need to troubleshoot what's need to be maybe something is very small missing. and then we can continue the further session. I think in BGP there's a lot to offer. As I said, the BGP, we just configure EBGP multi-hop. We configure the authenticate. We haven't configured the authentication, very simple. We configure IBGP route reflector, but we still need to have a route filtering, and as you just described, PS path, route summarization. We just play one attribute with origin. We have to play with MAD, wait, and ES path as well, and advertise, export community. I already showed them the multi-path thing, and then of course the redistribution. We did the route reflector. We still need to have a some BFD thing, route configuration, and of course some end-to-end testing further, and showing the audience the trace and everything.
Absolutely. So we've got the basic routing. Do we have enough to do trace routes through the system, or do you need to go back and we want to do that another day?
I think we want to do. I'll just save the config. So Mike, and we'll continue with, from where we are right now. I will not touch it, and we can troubleshoot altogether. I save the config of the devices, and can start from where we are right now.
Okay, so
that sound okay to you?
Totally fine. So this is what happens in life. You can be there with your lead architects. You got a plan. You're planning to do things, and certain things pop up on fire. So here's what we're going to do. Imran, you want to do this, finish this next week and do a second series?
Absolutely. We'll
Okay.
start from here, and I'll save all the config. We'll share the config with the audience as well later on. And I will save this lab and do the start where we stuck here right now.
Okay, perfect. So we'll do the following. I've told you guys that I would stay as long as possible up till 5 today. So with Imran, what did we do? We started building some networking things. Then we configured some IP addresses. Then we started configuring some routing protocols. Don't go anywhere, anyone. I've got you covered. After we did this, we did a little bit of looking at routing tables. So it seemed to me there was some little bit of confusion about certain things in the network. So let's do this. Let's have Imran and we're going to come back next week, and we are going to have a really fun broadcast section. And in between now and next week, I will stick around for the next hour because I told all of you that I would be here from 1 to 5. We will be here. And if you want, I will do some live network training. We can talk about routers. We can talk about switches. We can talk about interfaces on devices. We can literally talk about any network concept you want. Imran, like me, is highly requested and highly in demand. So if he needs to go and do something, I'll go back and play network teacher for the rest of the day. And I am more than happy to. So if you want to do some intro to networking, type intro to networking, and I'll start doing it now. We'll come back with Imran next week, and we will do an advanced series of this. We're going to take this base thing that we want to do right now. And from here, we're going to go deeper and deeper and deeper. But if you guys want networking, I've been in networking forever, and I'll walk you through it.
Yeah, I think the key thing is, aside from troubleshooting, I think that would be the part of our CCIE. Okay, troubleshoot, let's troubleshoot what went wrong. So we'll troubleshoot with the people, we'll simulate this again. The key thing is we still need to do is path manipulation, how the communities work and how do you path manipulate differently. And that's the different communities and different paths for BGP available. That is a very interesting part. Maybe we use the same topology, maybe we use another topology, but we'll continue to that. And apology, customer escalating. We have all live customer as well all the time, and customer escalating for something. And I booked the slot for 3-4 hours, but something's not presented, so apology.
Awesome, great. Like I said, in life, Imran, things happen. That's why many of us come from a world where we're taught to adapt, improvise, and overcome. So I'm going to do some intro to networking. Imran, every time I speak to you, which is pretty much every day, I am always grateful and thrilled for the opportunity. You brought so much today, and I am so grateful for sharing your knowledge with the community. I'm excited to know you. I'm excited to work with you. I got to tell you, you may see some really scary, deep networking things that they're at the CCI level, talking about how to become a cloud network architect or a network architect. And you know what? You're going to see some things coming from Imran and I too. But now, because Imran has some things that he must do, things happen last minute, I will do it. Guess what? It's a really big day for me. 3 days ago was my birthday. Today is my absolute 25th wedding anniversary. I am married for 25 years. My wife is still doing gymnastics because she does gymnastics like a 13-year-old, and I think it's kind of cool. And you know what? Now it's time for networking. So Imran, I want to thank you for all your help. I'm truly grateful for your experience. I will give you a call tonight before I take my wife to dinner for our anniversary. And in the meantime, thank you so much.
Great, thank you, Mike. And reach out to me if any question, I can respond right now.
I sure will. I'll call you tonight. Thank you again for your help. You can do what you need to, because when fires have to be put out, guys like you get called by the world's largest organizations when they have network outages and say, fix it right now. I know you're a firefighter of the network. So take care, do everything you need. Lots of appreciation, lots of respect. Let's do some intro to networking stuff, everybody. We'll do it on the fly. It'll be a little informal, but we're going to have fun.
Okay, thanks. Bye.
So, okay, let me see how to go back to this. I'm not Mr. Zoom, so I'm going to unshare everything. Chris, can you make sure that I can share my screen again?
You should be able to now.
Okay, so let me do this. How do I go to the center of the screen? Do I need to do anything? Because all I can see is, what am I going to do? I'm just going to pin myself now. If I pin myself, does that work? Chris?
You're in the middle of the screen.
I'm in the middle of the screen. I don't need to worry about it. Okay. Chris is my chief operating officer. Chris is the super smart person that makes sure that everything we do on the back end works. So a huge thank you to Chris. Now let's talk about some networking things. So realistically speaking, when we're talking about networking, we're talking about communication. In fact, we're actually talking about some communication which exists between point A and point B. So let's work on it. Let's talk about it. You know, people wanted an intro to BGP. So do you want a BGP lesson? You want me to do this live BGP lesson where you guys can ask some questions about attributes and things? We'll do it right now on the fly. We'll see how fast I can do a BGP lesson. You guys want intro to BGP right now? You guys want it at some point. I was going to do it on a different day. Imran has something going on today. He puts out fires. You want to learn about BGP right now? Because we can have some fun. We will talk about BGP from the beginning, the middle, and the end. You guys all ready for BGP? Let me know by typing BGP in the chat window, and we're going to go straight into a good 1-hour discussion on what is BGP, how does BGP work, and then when you are ready, next week when Imran comes back, we are going to do all this advanced manipulation that I'm talking about. You guys ready? Type AWS BGP, and let's get started. Oh, Basingi, when you meet Chris, you're going to realize what a great guy he is. He does so many great things for my students. He's a data scientist with an MBA. He's really, really smart. So let's begin.
Here I am, Mike. Everybody can see me for 5 seconds.
Okay, thank you for coming on, Chris. This is my Chief Operating Officer, Chris Johnson. He is behind the scenes. He makes everything work so great. Thank you so much, Chris. So what is BGP? So we're going to talk about BGP, and BGP is a routing protocol. Most specifically, it's an exterior gateway protocol. And I'm going to get a little nerdy here. I'm going to get a little in the weeds here, and I'm going to have fun with it. So I used to have this hat with propellers on it because when I was in school, somebody called me a geek. No, I was an expert martial artist, and somebody called me a geek as an insult. They called me a propeller head. So you know what I did? The next day, I went into class with a hat that had propellers on it. So I've been a little bit of a propeller head ever since. So that's how we martial artists deal with threats. We basically say, this is who we're going to be. So BGP is an exterior gateway routing protocol. And we're going to get really technical here. My apologies. What is BGP? It's a routing protocol. And when you want to learn routes, you've got multiple choices for how you do it. Option one is as follows. You can statically configure it. You saw how we had Imran do a static route, IP route, 192.168.0.0, 255.255.0.0, 1.2.3.4 as the next hop. Well, you could do that. Or, as you saw, we configured OSPF internally. And OSPF we use internally because it gives us fast and absolutely rapid access to our information, which is great. But what happens if we need to scale? What happens when we can connect to other people? With OSPF, we've got no route filtering for the most part. We've got speed. We've taken all these routes from all over the world. We got to run this SPF calculation following the Dijkstra algorithm. So when we're doing this, we're taking in a lot of information. It's too computationally expensive with an IGP. So we're using an exterior gateway protocol such as BGP for this. So that's why we use BGP. Now, BGP or routing protocols build a map. If I wanted to go to Chris's house, and I know he lives somewhere near the Tampa region, I think it's St. Petersburg, whatever. I live in the Palm Beach region. I need a map to get there. So I could do the following thing. Here is what a static route is. I make a map that says, take I-95 up to a certain level, and then make a left, and then go west, then go right, then go left. And I've manually defined all of these steps, hard, one by one. This is a static route. Go here, go here, go here, go here, go here. So that's what a static route is. By comparison, you've got a GPS in your car, and the GPS says, make a left here, make a right here, and recalculating. Nope, go straight. That's why we use a dynamic routing protocol such as BGP. We want something to calculate stuff on the fly. We want to redirect our traffic on the fly. That is the point of BGP. So BGP is used for this. Now, most of these routing protocols, and we were talking about OSPF, and they say, hello, 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 are you there? They use a hello. And those hellos are typically IP multicast. And they're multicast because they want to identify everybody on the subnet. Why do you use that with an IGP? You got to figure out who everybody is and what they can do. Now, when we're talking about this connecting to external organizations, now we're in a different layer of fun. We've got a filter. If I get information from somebody, I might not need all their information. If I'm connecting to the internet, do the internet need to know the innermost workings of the most private, most critical subnets of our network? The fact where our intellectual property exists? Of course not. If they did, they could reach us. If they can reach us, they can hack it. So when we're dealing with connecting and routing, we've got to use the right routing protocol for the right reasons at the right time. Kind of like prescribing a right medication to somebody, the right dose, the right patient, right medication. Well, when we're dealing with networking, got to get the information. So let's talk about BGP. BGP is a path vector protocol. Remember when Imran was there and you were seeing the autonomous systems numbers? That's the path. Now, BGP is unlike a multicast routing protocol. It uses TCP, which means it's reliable. One router forms a neighbor adjacency. They kind of establish a relationship, and then they start exchanging information. Now, they have different states when they load information, and we're going to talk about that finite state machine soon, but at least know what it is. And yes, I'm a little enthusiastic when I talk networking because I love it. If you don't have a network, nothing works. So when a good cloud computing world, learn the network. So BGP, as I mentioned, is used with scalability and tunability and traffic engineering. So let's look at it. So when we're dealing with BGP, we have a few messages. There's an open message, there's a keep alive message, there's an update message, and a notification message. What are these messages? Well, let's talk about them and how this works. So as soon as I establish a TCP relationship with the other router in my BGP peering session, we become neighbors. So what happens? First we do establish a TCP session. And how does this work? With the TCP session, you send a SYN to the far end. The far end basically acknowledges your SYN, sends a new SYN to you. TCP message is established. Thank you, Jeannie, very much. 25th anniversary, really excited. So So we establish the TCP connection. And then after we establish this TCP connection, we send an open message. And the open messages that routers are sending each other are identifying themselves. Hey, guess what? We're using BGP version 4. My autonomous system is 200. And guess what? These are the timers we use. So what do I mean by timers? You can tune these timers. Remember how I like to talk about load balancers? And I like to say a load balancer says with its keep alive, are you there? Are you there? Are you there with its health check message? Well, guess what? With TCP, you're sending messages to make sure they're there too, called the keep alive. So what is a hold timer? Basically what happens is you form a relationship, you send an update message, an open message. In the update message, you determine what form of BGP you're using. Right now, everybody's using BGP version 4. You send your autonomous system number and you send whatever timers you're using, meaning a neighbor goes away, for example, if you can't find it after a certain number of hello messages or keep alive messages. The whole time is basically how long it is, basically 3 or 4 keep alive messages that are missed. So basically establish a TCP session, send an open message, which identifies what you are able to do and your capabilities as a router. Now, after that, after the session is done, you gotta basically keep your session up. So how do you keep your session up? And everything else, they like, for example, with the health check, with a load balancer, are you there? Are you there? Are you there? You know what you're doing here? You're basically sending a keep alive. You're there, right? You're there, right? You're there, right? And if basically speaking, there's no message to come across in a period of time, then the peer doesn't send a keep alive to say, I'm here, I'm here, I'm here. BGP neighbor is taken away and all of the routes that were learned via BGP all go away. So they all go away. So what we're going to do, because this BGP stuff is really complicated, I'm going to talk for about 10 minutes, then we'll have a couple minutes of questions. I'll talk for 10 minutes, we'll have a couple minutes of questions. So the next message that you need to understand is something called an update message. So remember, Imran configured a BGP session. So first thing that came is we had a TCP connection, then we sent an open message. Then we have keep alives going, I'm here, I'm here, I'm here, don't forget me. That's how we know. Now, let's say a route that was in our routing table went away. Well, if that route's not here and we continue to send traffic to that destination we have, our traffic dies. We want to withdraw that route so we can take another path. Remember that recalculating in your GPS, we have to have that happen here too. So that's what we're going to do. So we're going to recalculate. And how do we do that? If a message is lost, for example, or a neighbor goes down, we're going to send an update message, which basically pulls all things. And guess what? If we learn new messages, we're going to send an update that says, I've got it, I've got it, I've got it. So that's the message. So let's go back to these messages. Open basically says, hey, by the way, I want to form a neighbor relationship with you. This is what I've got going on. After the neighbor's up, keep alive. I'm alive, I'm alive, I'm alive. Guess what? I'm still here. Update message. You gain a route, lose a route, withdraw a route, add a route. You send your neighbors an update. Guess what? Here's the new route I learned. Now, after that, there's something called a notification message. A notification message is not a good thing. A notification message is sent where something bad goes along the way. If you get one of these notification messages, it's not a good thing. So you're going to be doing some debugging. And guess what? When you're dealing with routers and switches or any tech, you're going to be debugging. So let's talk about that. Now, I want to talk about how BGP forms a neighbor relationship. And we're going to talk about this machine. But before we get to the machine, are there any questions on BGP? For example, what it is, why we're using it. I like to start at the elementary levels. And since I have the opportunity to do it today, we're doing it on the fly. So it's a 25th wedding anniversary special of BGP on the fly because Imran got pulled into a firefight, which is totally cool. Thrilled that he's doing that, helping his customers. That's what good architects and good engineers do. Any questions for me right now? I'll pause for a minute to see if there's any questions. I'll type it in the chat window because there's about a 90-second delay. And if they're not, I'm going to keep going into BGP, but I want to make sure we answer everything. I want you guys all to do great. Typing in the chat window because I know how long the delay is. I'm going to wait for about 30 seconds, 45 seconds. see if any of you wonderful folks out there have any questions on BGP. And if not, I'll start talking about the finite state machine. Chaitin Nayak, let me answer your question here. These are great questions. Keep them coming. Do you have to manually configure the routers to translate these messages and take action, especially for notification messages? The second you configure, Chinchen, a BGP session, automatically these messages occur. So basically these routing protocols are just algorithms and they have a set thing to do. So as soon as we establish a neighbor relationship, the open message is immediately sent. After the neighbor relationship is established, the keep lives happen automatically. If we learn or lose routes, those updates happen automatically. And if we get a withdrawn message or we get that kind of notification message, it's because something bad happened. Maybe the TCP connection was shut down, for example, or we ran into a problem somewhere else. So, Chintan, I hope I answered your question. Generally speaking, notifications are not a good thing. Mr. P, after BGP, what's the next big thing? Well, realistically speaking, I don't really think for a while there's going to be nothing other than BGP. BGP is the only protocol that's really used to connect to external entities. I'll tell you what other things are coming though, Mr. P. And Mr. P, I got to tell you, I've seen the speed that you learn, and I've seen your ability to multitask, and it is impressive. I meant to actually write you a note after seeing how impressive you were in Monday's class and the way you were actually and the environment for which you were actually learning. It was unbelievable. So BGP is realistically the routing protocol that is used to connect to external entities. Now, is there anything else going on with networking? Sure. There's something called software-defined networking. What software-defined networking is, and it's going to come into play soon. Typically speaking, on these routers, you've got the control plane, which are the things that determine how do you move your traffic. What is the control plane? It's OSPF, it's MPLS, it's BGP. And you've got a data plane or the forwarding plane, which are your routers and your links. With the cloud, guess what? You've got your servers and your storage, that's your data plane. You've got these hypervisors and container orchestration services, that's the control plane. Same thing, old network, old technology in a new environment, now it's the cloud. It's all the cloud. Every one of these things are the cloud. So I do see software-defined networking. What is the difference between software-defined networking and BGP and traditional networking? Traditionally, all of this stuff is on the router. Literally, all of it's on the router. So you want to learn what's on the router, you go to the routers. Now, with SDN, you've got these controller modules on these big giant servers somewhere else. And these big giant controller modules are building maps of the network. And they're looking at things such as link speed, link congestion, latency. And SDN, your traffic will be rerouted around the internet into an environment that gives you near direct connection like performance. Remember, internet performance is typically not good. Why is internet performance not good? I'm going to tell you right now. You have guaranteed access to your speed to your internet service provider. But once your traffic gets on their network, you've got no guarantees. If your network has to go through 10 internet service providers to get to its destination, guess what? Your network goes through 2 internet service providers, and after it leaves yours, there is no guarantee of anything that's going to happen with your traffic. So because of that, you've got nothing. And that's why organizations use private lines or direct connection instead of VPN. But with software-defined networking, these controllers, which are off of the network, can literally take your data and reroute it based on latency, speed, performance, lack of congestion, and give you private line or MPLS-like performance over a public network. So you will be seeing a lot more SDN coming. SDN is at its very infancy stages. BGP is going to be used by 99% of organizations to connect to the cloud for long periods of time, meaning at least a decade and maybe more. But this SDN technology is getting better. My friend Kumar Mehta, for example, the one and his brother Apurva Mehta, the founders of Versa Network, have a very good SDN solution. Cisco has got a very good SDN solution. Juniper Networks has got a very good SDN solution. And there are some new and innovative providers that are doing this. So that's where I see the future. BGP for a while, last MPLS and label switching, like people like me that have done traffic engineering. But now we're starting to look at SDN and we're taking it real seriously. So Mr. P, I hope I answered your question. Let's get back to BGP. And when you guys ask more questions, we'll do it. But I've been told by my team that I should actually act like a YouTube person. So if you're enjoying this video, if you can please leave a like or a subscribe. And if it's appropriate and fun, if you want to forward somebody else to this, we would absolutely love to kind of work with you guys. So let's go back to the neighbor relationship. So when BGP forms a neighbor relationship, it goes through what's called a finite state machine. What do I mean by the finite state machine? There are things that actually occur through the entire steps along the way. So as follows, we get an idle message, we get a state called idle, connect, active, open sent, open confirm, and establish. So we'll walk through these and then we'll talk about how to tune traffic. That's where the fun is. The first stage is idle. So basically speaking, I've got two BGP speakers. I put neighbor 1.2.3.4 remote AS 400. And instantly I come up as idle. Now what's going on is idle. My router's up, the other router's on the far end. We're trying to form that neighbor relationship. Until the TCP connection is established, we are idle. Now, if we run into any errors along the way, misconfiguration, mismatch of BGP versions or something like that, we will go into idle and stay in idle. So we will never leave idle. Idle is a place where we want to be when we turn it on, but if we stay there for more than a second or two, this is bad news, something's wrong. So what is the next state? As soon as we start to form a TCP connection, we enter connect. And what happens, the BGP starts the connection, the process basically opens up and sends an open message to the neighbor. And guess what? We transition into open sent. This is what's supposed to happen. Now, if we can't establish a TCP connection, we can't send an open message to our neighbor because we don't have the session, we can transition to open sent. So if the TCP connection does not go up, we got a problem. What's going to happen is BGP is going to try and it's going to go to an active state. Active is not good. It should go to connect, open, open sent. But if it goes to active, something happened along the way. So here's what's going to happen. If the connection doesn't go through, it's going to retry in the connect state again and again and again. And if we can't find it, guess what's going to happen? It's going to transition back to idle. So you should start at idle, and then you should go to connect, and then open and open sent. This is what happens when things are right. When things go wrong, and when we're talking about tech, things always go wrong. They always go wrong, which is why, just knowing a name of something is never enough. You need to know how it all works, especially when it comes to troubleshooting. So that's what's going to happen. It's going to go to connect, open, open, sent. All things go well, but things aren't working the way they're supposed to be. Don't you worry. It's going to transition back to idle, and you're going to have to go figure it out. So what's the next state? So we already told you what it should be, but remember I said if you don't get the perfect TCP session or things don't work right, we're going to transition to this active state. Okay, let's talk about active and active transitions. In the active state, what realistically happens is you keep trying to reset the TCP connection for a few reasons. You keep trying to start the process. If you can't, you go back to idle. If at some point in the active state, the TCP connection comes up and you start exchanging messages, you got to open and open sent the way it's absolutely supposed to. Yes, Mohammed, we'll talk more about SDN in a little bit because there's many different definitions, but it all involves the separation of the control plane and the data plane for forwarding. So now let's talk about what should happen. Idle, connect, open message, open sent because it went through. Now we're in open sent. So what are we waiting back here for? Now we're waiting to get an open message from our neighbors. If we get an open message from our neighbors, it's like, okay, this is really fantastic. We've initiated connectivity to them. They've initiated connectivity to me. Ding, ding, ding. Everything's working really great. So now, if anything goes wrong, we go back to idle. So idle's normal in the beginning. It's what it's supposed to be. If you're in idle after a minute later, there is a problem. Go troubleshoot, go debug. So when you send that open sent and you're waiting for the open message back, when you get the message from the far end, you're now in something called open confirm. Basically, idle, connect, open sent, confirmed. You know what confirmed means? You received information. You're waiting for the keep alive from the neighbor. You get that keep alive from the neighbor, boom. It's like magic. You now transition to established. And when you're now established and that BGP neighbor is established, like Imran was talking about, you've got full neighbor connectivity. This is where the routing information goes. So this is really great. This is everything the way we want it to be. Open sent, open confirm, established. Life is good. In established, we are up, we are running, and this is where things go. So now we're going to talk about attributes. These attributes that we're going to talk about next are where all the magic happens in BGP. So before we go to the magic of BGP, we discussed a little bit of complexity about TCP opening up the session. So let's recruit very briefly. We talked about BGP being an exterior routing protocol that's used for scalability, tunability, and traffic engineering. We talked about it being unicast using TCP port 179. We talked about why we use it. What did we talk about next? We talked about the 4 states of messages between the open message, which is basically establishing the TCP connection, the keep alive message, which is basically saying, I'm there, I'm there, I'm there, I'm there, I'm there, I'm there. Yes, we're still here together. We're at the party. We're going to exchange routing information. An update message, which is I've got a new route or I've lost a new route. And a notification message. And what is that in the notification message? The notification message is as follows. Something went wrong, removed it, for example. So now you know the 4 messages. Now let's go back to that finite state machine and what's supposed to happen. What's supposed to happen is you're in the open state. Well, actually, you start with the idle state. And realistically speaking, you start in an idle state, which is exactly what happens. Then after the TCP connection is established, you go to connect. Then you send an open message. And if all else well, you go to open send. And if all is working, you get to open confirm, you wait for a keep alive. And if everything goes right, you are established. Ding, 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 everything's working. The magic's happening, getting your routes, you're reaching everything. What if you don't establish that TCP connection? What if you go to idle and you try and go to connect, and instead of sending that open and getting to open send, something bad happens, you go to active. Active is going to keep retrying the TCP connection and thing. If it doesn't get established, it'll transition back to idle. So idle is not where you want to be, except initially. If you stay on idle, you got to fix something. So prior to getting any more, because some of this stuff is pretty complicated, BGP is a CCIE level routing protocol. And unfortunately, it's the routing protocol that you need to use to connect to the cloud. Why do you use it to connect to the cloud? Cloud's exterior, they're an external organization. Do you really think AWS could take 1 million routes from 1,000,001 companies and still put them in there in an interior gateway protocol? Of course not. And that's why they limit the routes they need to take to you. Is 100 routes minuscule and incredibly small? Yes. Is 100 routes from 1 million organizations on AWS? Unbelievable number times 100 times 1 million, it is. So when you start looking at cloud providers, you got to look at the architecture of why they are what they are. Why do you have to limit certain things? Because they've got limitations, because they are so huge. So if you hear me saying small amounts of routes, get creative, they have to have a smaller amounts of route. How could they do it any other way? So can you get better performance in the network and the data center? Of course you can, because you're only dealing with your stuff. But look at the magic of the cloud provider. Look at the ability to handle thousands and hundreds of thousands of customers on a shared network media and still deliver some pretty good performance and still be able to deliver some pretty excellent security and be able to deploy something in seconds versus minutes while you're onto something is truly transformational. So understand the strengths and the weaknesses of all approaches. That's what makes you a great architect. When you know all your opportunities and all the things you can do to improve your customers, you're a great architect. So Mohammed, yes, every vendor has its own definition of SDN. SDN could be a little bit of something like a cheap router with a commodity router or switch with fancy software that's cloud managed. But generally speaking, when you're talking about software defined networking in the world that Imran and I come from, the Juniper Networks world, the Cisco Networks world, the really big Versa Networks world, the people that are doing 80% of the core internet routing. What we're talking about is separation of the control plane for the data plane, and using the separate control plane to really manage your traffic based on intelligence that it finds in the system. So, Mohammed, I hope I got to your question. And any more questions, I will also type it in the chat window because I know there's delay prior to moving on to the next section. So let me ask us. Why am I typing it here? Because that 60 to 90-second delay, I don't want any of you to miss any opportunities whatsoever, anywhere, anytime to learn. So please understand that. So while we're at it, I'm going to check and see one quick thing. Any questions for me? If you've got any questions, we want to answer them. We want to be a source of information to help you in any way we can. Your cloud computing careers, your network careers are really important to us. Mr. P, since you have to manually connect every peer connections, on average, how many are we talking about? Wow, what a great question. So it depends on the complexity of your network, Mr. P. For people like me that have worked on these large ISP networks, we could be dealing with thousands upon thousands of routers that all are doing IBGP pairing together with on our own networks with multiple route reflectors and something called confederations, literally thousands of them. When we're dealing with the cloud, here's how simple it's going to be. We're going to peer to AWS, maybe, for example. We may peer to Azure. We may peer to GCP. Realistically speaking, that's 3 sets of peering sessions. Now, anytime we're using direct connections, we're using peering. On VPN connections, we could be using peering. Anytime we're using Cloud Hub, for example, or Transit Gateway, Mr. P, with AWS or the Azure equivalent or the GCP equivalent, you're going to have BGP pairing sessions. So what is Cloud Hub? And we'll map it out soon. Cloud Hub is a way that you can use EBGP connections to create a hub and spoke routing environment. So if you had 100 VPCs and you're using Cloud Hub, you'll have 100 VPC pairing session. If, for example, you were going to fully mesh your IBGP pairs because you weren't going to use Cloud Hub, or your VPC pairs, you would have a whole lot of BGP pairing going on in your environment. So next question for me, Mr. P, what can we use to map and confirm these connections? Well, on your router, you'll be able to do a show IP BGP neighbor, and that's all you're really going to need to see. You'll be able to connect it from the routers to your things. Now, when you're going to, the reason I say check from the routers, when you're going to connect to AWS, they're going to have their own thing. Now, they have their own virtual routers, and therefore you can easily see your routing tables with the CLI or the management console. But when you're really talking about getting into your BGP tables and really see what's going on when you want to really look at these messages, go to your router. The Cisco router will give you 1,000,000 times more diagnostic information on your connection than you're going to get from the cloud provider. Why? That's all the router does. The router only has to do one thing. And because it only has to do one thing, it's going to do it better and faster than anything else. The cloud provider is amazing. They've got a control plane layer of software that's literally doing anything. Network virtualization, server virtualization, container virtualization, storage virtualization. I mean, they're doing a lot. So when you're a jack of all trades, you can never be as good as something that focuses on it exclusively. So when I need a firewall, I get some from Cisco or Checkpoint or Palo Alto or Fortinet. I use an industrial grade firewall, put it on an EC2 instance because that's all they do. But I do this for super high security environments. In modern environments, I use the cloud native services. When I need real heavy network stuff, it's going to be on the network itself. So Mr. P, show IP BGP neighbors, and that's going to show you all your BGP peering sessions. Hope I answered your question there, Mr. P. Who else has any more questions? Does anybody have any more questions before I go on to more content? If not, I will go on, but I'm going to wait 30 seconds to see if there are any more. So while we've had an audience, there's been over 4,000 people so far that have participated today, which means we are excited and thrilled to share our knowledge and create the next generation of future cloud architects and network architects. I'm going to get back to the presentation. I've done my 30 years in tech, almost 30 years. It's time for people like Imran and me to create the next generation of leaders. We're not going anywhere. We're still here. We love it. We're not getting out of this, but somewhere along the line, we need to train newer people so that newer people can get involved and have the magical careers we did. So that's why we're doing these sessions. So if you need any kind of session, you want any kind of session, you want me to produce content, tell us in the chat box, send us an email to Ask Cloud Mike. I will run it through my production team and we'll research the concept. Leo, inside of an organization, what requirements would define whether if you use IBGP or OSPF? That is an extraordinarily good question, Leo. Inside an organization, you're always going to use an IGP. An IGP is used for rapid speed, rapid convergence. So you will always use something like OSPF inside of your organization. Now, when you want to connect your organization to an external organization, Leo, that's when you use BGP. So OSPF is used internally, BGP is used externally. So realistically speaking, think everything inside of your house uses an interior gateway protocol because it's inside of your house. If you want to connect your house to somebody else's house, like you want to connect, let's say your house and your network to my house and my network via VPN, and then you want to run BGP to route between, with BGP, I could give you access to, say, my VPN subnets and my demilitarized zone. And I could not give you the information to reach my production subnets where my information is stored. That's why we're using BGP, to connect and filter and scale to when we connect to external organizations. So internally, OSPF or EIGRP or intermediate systems to intermediate systems. Externally, like between your data center and the cloud, BGP. Externally, between your data center and your internet service providers, EBGP. Hope I answered that question. Why would you use IBGP? There's only one reason you use IBGP. If, for example, I learned information from AT&T and I also learned information from Verizon, and I want my network to know, my whole network internally to know which paths Verizon does better than AT&T versus which ones AT&T does better than Verizon, I would run IBGP across my network so my internal network would know. I probably wouldn't do this in real life. I'd probably just inject the default route into my IGP, but IGPs like OSPF inside your network, EGPs just like for external networking, and that's what you need to know, and that's how it all works. So hope that makes sense. So now that we've gone through the finite state machine and we've gone through how we set up a connection, let's do this. Let's now talk about the BGP attributes. And then if you haven't seen this, when Imran and I come back next week, it's gonna be super, super fun and will actually make sense. So our BGP has something called an attribute. And an attribute are simple knobs. We used to call them nerd knobs. An attribute is something about the route that we actually learn. So maybe we learn the weight. Maybe we learn the number of paths it's referred to. It's kind of, this is what we talk about when we talk about BGP attributes. So I know BGP is fun for me. I know I get excited when I talk about BGP, but I got to tell you, I love this routing protocol. It can do so many things. So now we're going to talk about the attributes. So there's a bunch of different attributes. Remember, today we worked on the origin attribute. Okay, what is the origin? The origin attribute kind of tells us exactly how we learned the route. Did we learn it from our IGP? This is preferred. Did we learn it via BGP? This is not preferred. Or did we just redistribute it connected and not set a metric, in which case it's going to show up as incomplete? So attributes, remember, learn from your IGP, most reliable. Learn from your EGP, second preference. Incomplete, not good, last choice. So when Imran made that route map today, and in that route map, what he actually did is he changed the origin code from incomplete to something else. Well, then, these things happen. So let's look at the next one. It's the next hop attribute. What is the next hop attribute? Let's talk about it. So the next hop is the IP address where you would send your traffic to next to reach the destination. I'm going to tell you, everything that doesn't work in BGP, most of the time, it's because you can't reach the next hop. So when Imran was doing a show IP BGP, he could see the BGP route and the next hop. When I was doing a show IP route, I was seeing which routes that were learned from BGP were placed in the router's routing table, which is going to determine where our traffic is forwarded. There were two different things. He's looking at the BGP table. If it's not in the BGP table, it can't be in the routing table. And then the routing table shows up. So the next hop is where we're going. So let's talk about this first attribute. The first attribute was the origin code. Hey, how'd you learn it? The next attribute is the next hop. Now, these are where it starts to get fun. And the reason this starts to get fun is this is where we can do our traffic engineering. So these next things are really, really important. So the first attribute is called the weight. What is the weight? Weight was a Cisco proprietary attribute, but AWS and others support it as well now. Weight is as following. The higher the weight, the more preferred the route is. That's it. It's an attribute local to the router. The higher the weight, the more preferred the route is. We'll talk about more about that in a minute. We'll walk it through. Next. So we're going to prefer the highest weight. If the weights are now equal, guess what else we're going to prefer? The local preference. So prefer the path with the highest weight. This is the decision algorithm. Next, prefer the path with the highest local preference. Now, if the local preferences are the same, remember this is super important. In fact, I'm going to actually paste this because it's so important into the chat window. So we can do some, okay, that's not going to work as well as I thought it would. So let's try and do this. So this is what happens when you are not Mr. PowerPoint. And so let's do this. So I'm going to let you know, these are the attributes in order. Prefer the path with the largest weight. Next, if the weights are equal, prefer the path with the largest local preference. If the local preferences are the same, take the one that was originated locally on the router. Now, if all of that is equal, we're going to take the one with the shortest AS path, shortest number of hops. So that's next. That's why I put it in the chat box. Now, if all of this is true, then we're going to use the one with the lowest origin code. Remember, IGP is preferred over an EGP, and that's better than incomplete. And that's why Imran, when they redistributed connected subnet, added an origin code. So then where are we coming from? If the origin codes are the same, then prefer the path with the largest med or the lowest med, multi-exit discriminator, the lowest metric to leave our autonomous system. And if the meds are the same, prefer EBGP routes over IBGP routes. Oh, wait, wasn't the administrative distance automatically lower too when we looked through that before? Now, if the routes are equal, we're going to start getting into goofy stuff. Prefer the path with the shortest path to the next hop. Okay, so they're there. Like I said, like Mohammed, weight is only locally significant and it's not available on all routers. It is available on Cisco routers. It is available in the AWS environment and certain other routers as well, but it was Cisco proprietary forever. Then, now, if the routes are the same, and the reason I'm giving you guys this is we're going to work through some scenarios, and I want you to tell me which one would go. So let's do this. So then you start picking stupid stuff in the end of the equation, like lowest IP address, highest IP address. So now you know kind of where we're at. So you know what BGP is, you now know the decision algorithm, and you know some of the attributes. So what are we going to do with this? Well, let's have some fun with it now. So let's do this. Let me work through some slides with you now so we can take some situations. Okay, BGP. Can you guys all see my desktop with some PowerPoint slides right now? Now let's go. And I want you guys to all look because we're going to be tuning traffic engineering. Now, in this particular environment, we have our data center connected to our cloud. Now we're going to have fun with all that cool BGP stuff we were talking about. BGP stuff is fun. So because of this, what we're going to do is as follows. Oops, we're going to do this. Oops, I don't exactly know what happened. I'm there. That's why I'm not Mr. PowerPoint, but that's okay. So we've got two connections. Let's say we have two direct connections to the cloud. Now, I'm going to tell you first, before we even get to any kind of BGP attributes, routers always prefer the most specific path to a destination. Meaning, if you've got a /15 and a /16, you will take the /16 over the /15 because it's a longer prefix list, which means it has more information. So now you get it. So in this situation, note, I've got two direct connections to the cloud. I have not manipulated BGP policy at all. On the top link, I am advertising a specific subnet to 172.16.0.0/16. I am advertising a summary route, which covers all the CIDR range of the data center on the top link. On the bottom link, I'm advertising a 172.17.0.0/16. And I'm also advertising a 172.16.0.0/15. Okay, what have I done? I've got a specific route on the top link, I've got a specific route on the bottom link, and I've got this summary route that covers our whole CIDR range. Under normal circumstances, which link is going to be used for 172.16.0.0/16? Tell me in the chat box, am I going to use the top link or the bottom link, knowing that routers prefer the more specific route? Let me know in the chat box, top link or bottom link. Who we taking to 172.16.0.0/16? Architecture in action. Someone out there, Mr. P, Mohammed, somebody's got a networking background, or even one of the cloud computing people. Which route has a more specific route? Which link is going to be used for 172.16.0.0? Let me know in the chat box. Peter Hunt, excellent. We're going to use the top link. Anybody else? We're going to use that top link for that 172.16.0.0 because it's more specific. Does everybody see that? Guys are awfully quiet. It's not like a Zoom meeting where I can see your faces or talk to you. So please let me know. And if we're taking 172.16.0.0 for the top link, John Thompson, great job. Anybody else? Great job. Leo, great job. Okay, I know it's a little tricky, everybody. Nick Love, great job, top link. Excellent, you got it. 172.16.0.0/16 is the top link. Mr. P, excellent. Good job, everyone. You're making me happy. It's gonna be some heck of a 25th anniversary. 3 days ago was my birthday. I met my wife at 21, married her on my 23rd, 3 days after my 23rd birthday. And today we've been married for 25 years. So anyway, I'm just excited. It's a good day. And you guys are getting BGP, which is the most complicated and ugly of all the routing protocols to learn. So I'm excited. Now, 172.17.0.0.16. Can somebody tell me which link that's going to be the primary link under normal circumstances, please? 172.17, which link is going to be used? Which has the more specific link for 172.17? I know there's a big delay, so I'm going to give you a little bit of time. Tell me which link is more specific for 172.17? So 0.0/16, the top link or the bottom link? Leo Pratt, great. Bottom link, absolutely. Yes, 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 great job. Bottom link is more specific to the 172.17. John Thompson, excellent. Nick Love, excellent. You guys got it. Now, does anybody know why I'm even advertising this CIDR range of 172.16.0.0.15? Gold star for anybody that knows this one. If not, I'll tell you. Mr. P, Nick Love, Alonzo, Pete, Hunt, Reginald, great job. You guys are getting it. Why am I advertising The 172.16.0.0/15. Amaranth, good job. RNRFR, excellent job. Now, why does Mike feel the need to advertise the 172.16.0.0/15? The entire CIDR range on both links. Why would I do that? If you guys don't know, that's okay. I'll tell you, but I want you to know because it's really, really important. Let me know. Nick Love, got it. Wonderful. In case one goes down, Amaranth, great. So if I lose one of these links along the way, if I lose a link, guess what? I have the whole CIDR range advertised on the other link. If, for example, I did not have that other link, I would not have network reachability. So John Thompson, let me explain this because it's a good question. If we have only 172.16 on the top link, and we only have 172.17 on the bottom link, if we lose the top link and I've only advertised 172.17 on the bottom link, what happens is as follows. I don't have access to it. So what I'm doing is I'm sending a CIDR range, which includes all of it. So what I'm doing is on the top link, I'm linking, which is a different connection. I'm linking a specific route to make that more preferred. On the bottom link, I'm linking a more specific route, which will be more preferred. Now that CIDR range will never be used because we're going to always take the more specific routes. But if the top link were to go away, the bottom link has access to 172.16.0.0/15. What does that summary route have and mean? It means I can connect to the 172.16.0.0/16 subnet and the 172.17.0.0 subnet. So what I'm doing is I'm leaking a specific route to traffic engineer my traffic, and I'm sending an aggregate route. If one of those links goes away, I still want to be able to reach everybody. So that's what's going on. Now, let's do it another way. Let's change the weight. So weight is local to the router. And because weight is local to the router, if we can change the weight of a route, we can make it more preferable or less preferable. The higher the weight, remember that algorithm I pasted in here, the larger the weight, the more preferred the route is. So let's take that route with the higher weight and let's go do something about it. So what are we going to do? On the top link, let's say we want to make the 172.16 preferred. Guess what? We give it a higher weight than the other one. And let's say in this situation, we take the bottom subnet, we take the 172.17, and we don't want to use the top link. Basically speaking, we reduce the weight. Now, we're going to go to the bottom link. We're going to prioritize that 172.17.0.0/16 by increasing the weight. And we're also going to reduce the weight for the link, the subnet we want to use the top link, the 172.16.0.0/16. What have we done here? We have verified that under good circumstances where everything is working properly, we are going to be using the top link because it's most specific, meaning it has the highest weight for this 30 things. The routing table that's going to be sitting here in the router is going to say, guess what? I have the best route to 172.17 over the bottom link and the best route to 172.16 on the top link. Why? Because it's got a higher weight. Now, why do I still advertise both on both links? What happens if the bottom link goes away? Now, the top link knows how to reach both subnet. Why? Because they're both there. We advertise both routes. And what would be naturally the more preferred one on the lower link will be more preferred for 172.17. But if that lower link is gone, it's dead. There's nothing there. We still get the two routes from the routing table up top. That's why we're prioritizing one on one link and one on another link, but we're still using the lower weight for the backup. Is that clear to everyone? If it is not clear, I will go over it again because I want you guys to understand this. BGP is cool. You guys get that? Give you guys a minute to ask. If you see me going from one monitor to the next monitor, like looking in different directions, I'm trying to watch the stream on one monitor and then be able to see the questions on another monitor. So bear with me. So It's not really an EBGP multi-hop situation here, Mohammed. I'll talk about what that actually is in a minute. What's going here is, does everybody understand why why we have both weights on both links, one prioritized, one not prioritized, in order to make, okay, so Derek, yes. So what we're trying to do is we're making sure if one link goes away, we still have a secondary link. And because of that, these are kind of one of those things that we're looking to do. So these are those things that make us happy and excited, realistically speaking. So does that make sense for everyone? Okay, perfect, it's clear. 1 second. Okay, so now everybody's got this. Now let's go back to Mohammed's question on EBGP multi-hop. Okay, well, the EBGP multi-hop is as follows. If I've got one link, let's pretend my arm is the link. On one side of the link, let's say we have a 192.168.1.1, and on the opposite side of my arm, we've got a 192.168.1.2. On this, typically speaking, we would do, if this is 192.168.1.1, we would typically set up a neighbor relationship with the remote AS with the 192.168.1.2. That's normal, that's standard. So what's actually going on here is, and that's typically, we would have a direct connection. So you wouldn't need anything called multi-hop. Now, if you are going to go loopback address to loopback address, meaning you have to traverse the WAN link and another subnet, that's called EBGP multi-hop because it's not direct. You basically have to go over more than one connection. So loopback to loopback connections are why you would use EBGP multi-hop there, Mohammed. So that's why we're actually doing this. So now that we've adjusted the weight, we're going to have some other things that we can do. We can manipulate local preference or AS path, and guess what we're going to? But understand how we manipulated traffic first by leaking out more specific routes. Secondly, we actually did so by, what's the word I'm looking for? By manipulating the weight. So what's next? Local preference? Let's do that, but let's answer Mr. P's question. The blue routers are actual real routers that are actually sitting in the organization's data center office that is connected to the cloud. Absolutely, Mr. P. The cloud, you've got these virtual routers, which are logical routers sitting on servers somewhere along the line, but these are real routers with real performance. So, perfect. I hope I answered your question. So next on the list, we've tuned the weight. Local preference is next. Okay, we've changed the weight. Now we're going to change the local preference. So with the local preference, let's do this. So let's say on the top lane, remember the larger local preference is the winner. So instead of changing the weight, which we previously did, we could have just changed the local preference. By changing the local preference, lots of things happen. So you change the local preference. On the top, look what we did. We prioritized the subnet 172.16.0.0/16 with a local preference of 200. We took the lower subnet 172.17.0.0/16. On the bottom link, we flipped it. So somebody tell me which path is going to be chosen for 172.17.0.0.16. So which has the larger local preference for the route 172.17.0.0.16? Which path will the routers take from the cloud to go back and reach the data center for 172.17.0.0.16? Which one, guys or girls or everyone out there? Which router? Which link? Which has the highest local preference? Jeannie, which has the higher local preference for 172.17.0.0? The top link has a local preference of 100 for 172.17.0.0.16. The bottom link has a local preference of 172.16.0.0. Which has a larger local preference? Leo Parades, you got it. 172.17.0.0/16, the local preference is 200 on the bottom link. Where on the top link, it's only 100. Prefer the path with the largest local preference. Now, at some point, you're getting with highest and lowest IP addresses, but we're going to manipulate the things before we get there. Pete Hunt, great. Leo Parades Hunt. Jeannie, I'm sure you're going to get it real soon because you got the last couple. Nick Love, bottom, excellent. Jeannie, you got it. Derek, great job. Okay, now, when Imran and I were doing this show, IBGP, and we were having a party with it, he's configuring things. He's doing all that tech piece. I'm kind of explaining the tech. Most of my career has been as an architect. You know what half the job of an architect is? Translating between genius engineers and executives. Got to tell you, it's half the job. So I like translating. I learned how to do this. When I watch a movie, my wife tries to translate it to me. There was a period of time where I didn't speak Greek when I married my wife. And so she used to translate Greek things to me. You know what she does now? When she doesn't remember, she translates English to English, and it's really cute and really fun. But all what we do as architects, half of it is translating between the genius engineers and the business people. So now we're going to prepend AS paths. Prefer the path with the shortest AS path. Prefer the path with the shortest AS path. So given that scenario, which has a shorter AS path for certain routes? Look at the top link. We are one hop away from 172.16.0.0/16. And because we prepended, or we added AS paths, which Imran will walk you through on another one, for 172.17.0.0/16, we're 2 AS paths away, meaning twice as far. Now let's go to those bottom links. Okay, with the bottom link, what do we see? We see as follows. A 172.17.0.0/16 with a short path. And we see a longer path of 2 autonomous system hops for 172.16.0.0. So from the audience, people, please tell me which link is going to be chosen for 172.16.0.0/16, and also tell me which link is going to be chosen for 172.17.0.0. Please let me know, guys, right now. Guys, girls, anyone out there, let me know. And if you get this, you're really getting BGP tuning and traffic engineering. Let me know in the chat box. Okay, I'll give you some time. I know there's a pretty massive delay. Tell me which link is going to be used for the 172.16 based upon shorter AS path, and which link is going to be used for the 172.17.0.0/16 based upon the shortest AS path. Please let me guys know that you're here, you're awake, alert, and oriented, and you're getting BGP by putting in the answers to the chat box. Okay, Eric, yes, so which subnet though? Is it the 172.16.0.0/16 that's going on the top, and the 172.17.0.0 on the bottom? Is it vice versa? Please let me know which subnets are where, guys, so I know you get it. Well, what's going on, sometimes when we see people that are starting to talk about local preference when we're talking about AS paths, is what's going on is there's a delay. And sometimes people turn in 60 seconds later, they could be seeing different portions of the video sometimes. So Peter Hunt, top link 172.16. Stellar job there. Bottom link 172.17. Excellent, excellent job, Peter Hunt. Great job. Anybody else see the same thing? Derek, you got it. Derek, you once asked me if beyond a certain point in our lives, can we still learn? Derek, you're doing CCIE level routing on a month and a half of knowing you. Unbelievable, Derek. Reginald, excellent job. Good job, everybody. Good job. Okay, one last metric we're going to manipulate, the MED, the lowest multi-exit discriminator. So in this case, we've gone back to the same environment, and I've decided to play with the MED instead of the weight, the local preference, or the AS path. Prefer the path with the largest, lowest MED, the lowest multi-exit discriminator. Look, I don't make up these terms. I call things simple. I call this a cup of water, whether it's a cup, a bottle, a glass. I don't have a million and one terms. I keep things simple. I like it that way. It's much easier. But, you know, we got a lot of tunes because some things are local. Some things like the AS path, we can prependence and upstream. So let's choose the path with the largest MED. Going back to this situation, which path is going to be chosen for 172.17.0.0/16? Which has the lowest MED? Let me know, guys. Guys are doing unbelievable. Which link do we choose for the 172.17 by modifying the MED metric as stated in this PowerPoint slide? Somebody help me. Derek, slap 172.16 on the top because of the reduced MED. Excellent. Which means Peter Hunter, 172.17 is going to go over the bottom link. Excellent, because it's got the lowest MED, multi-exit discriminator. Amrath, good, you got it. Okay, this is some good, exciting stuff. What did we do today? We went through this thing, and bear with me, and we picked paths. And we've chosen routes based upon the most efficient routing. So we started with, doing some configuration. Then we talked about what is BGP. After we talked about BGP, we talked about why is BGP used. After we talked about why is BGP used, we talked about the BGP messages. Then we talked about the finite state machine, open send, open confirm, that kind of thing. Then we talked about BGP attributes. Then we talked about tuning BGP. So we did an on-the-fly enter the BGP class. What questions did you guys have fun? If you think BGP is pretty cool, type AWS BGP in the chat window. Let me know you're there. Type AWS BGP. I'm proud of all you guys that have participated. I'm proud of all of you that have put answers in. I'm proud of all you guys that have not been afraid to come off mute, enter information, and just try it. You guys are doing absolutely fantastic. Coaches like me that have been working and spending a lifetime trying to breed the next generation of technology people get really excited and really happy when we see people learning this fast. So Ken Me, thank you, AWS BGP. Leo Parades, AWS BGP. If you guys are having fun or learning BGP, type AWS BGP, Alonzo, Peter, Derek, Amaranth, Reginald, Jeannie, awesome. John Richards, AWS BGP, you got it. So BGP is cool. Sarah Smith, Alex, Jonathan Brown, welcome. We're so happy to have you here. And we'd love to hear from you. Alexandra Johnson, excellent. Alexandra Prisak, wonderful. BGP, BGP, BGP. I got to tell you, you want to work on the cloud? Obino, thank you. The Johnson 86, AWS BGP, thank you. I'm here with you. This is routing. This is cloud networking. This is things for network architects. This is things for cloud network architects. And this is things for cloud architects. you're not going to find this critical information covered in certification materials. But guess what? You need it for the job. Richard Rich, excellent. So that's why we're doing these things. We're bridging the gap between the stuff that certification teaches you and the things that are necessary for the job. Leo Paredes, thank you. Cloud Learner, thank you. Cloud J, thank you. We love BGP. BGP is so tunable. Derek Houston, my knowledge is, thank you so much for these extremely kind words. I gotta say, I have never imagined how awesome it could be to literally go from YouTube, share the experiences I've had for the last 2.5 decades with the community. This is the best feeling you can imagine. When you guys all learn things, and I get emails from people every day all over the world telling me I got a first cloud job, we are so excited. With regards to Mohammed's, I think you're actually watching a slightly different part of the presentation right now, but when we were all synced up during the presentation, you had some incredibly valuable things, and we loved it all. But if you have the local preference that's the same, the path is the same barrel, then the med's going to come into place. Absolutely, you're completely right. So Simon Cordova, there is no reason to donate to these classes. We are just excited to be part of the community. Chris from my team will put out, we have a cloud architect career development program, which is literally something that summarizes my 25 years of experience of creating architects and helping people get their first cloud job. And we do it better, faster, and far cheaper than anybody else that offers a single program. I've been in this world forever, and I want to raise the next generation of technology professionals. So to let you guys know, we have all new gear coming here. Currently, we're using Sony professional cameras and Sony professional lenses and a professional grade of microphones. But I found that coming online and interacting with the community, see, my birthday happened the other day, and I received messages that brought me from tears. Messages from India, Pakistan, Asia, Africa. I mean, all over South America, thanking us for the free content. After I was in tears, told my wife, showed her the messages, and she says, oh my God. So I basically bought all new Sony cinematography gear, meaning the stuff they make movies out of. And it's going to be here today and tomorrow. Next week, as soon as we get our gear tested up, we are going to be doing a lot of free training. In fact, we may almost have a live stream show of the day for about an hour. We're going to talk about all these things that are current, all these things that are going on, anything you need to know for your cloud computing careers. We're going to bring that to you. So if you want to be one of our students, we'd love to work with you in our Cloud Architect Career Development Program. Our students get the most elite training in the world. We can easily charge $20,000, $25,000 for this training. My students in the class will tell you that. We don't. Our mission is as follows. Basically train the next generation of technology professionals at a cost that's basically 1 to 2 days pay for people in their fields. And that's it. We are just a solution provider. I've done all the work I needed in my life, and now it's raising the new generation of tech. So if you guys are excited about the concept of a daily show and more technology, please let me know with more live streams in the session. In the meantime, I'm going to ask Simon Cordova's answer. You've been programming for 6 years and now getting into architecture. You're thankful for this. You're welcome. Programming is great. Architecture is the best job I have ever had. I practiced internal medicine first. I became a network engineer, which I love. I mean, I really enjoyed it. And then I became a network architect first. And let me tell you, that meeting with customers, that designing of technology solution, that solving customer business problem, oh my God, best experience. And when I went in there and I focused on my executive presence and trained soft skills, emotional intelligence, communication skills, presentation skills, I went from a good career to a rocket ship career. And that's why people that know me know that I am obsessed with training soft skills and emotional intelligence in these skills. They will build your cloud computing career, your cloud architecture career, your network architecture career faster than anything else in the world. So I'm super excited to work with you. If any of you guys had any questions on our training, you can call our office. Somebody always asks us our phone. This is our office number. Does anybody have any final questions for today? Any more questions for me? Questions on BGP, questions on OSPF, questions on router, questions about cloud computing careers, or questions about networking careers? I'm here for you. Just post your question. I'll do anything I can. So let me know if you have any questions before we end the session. We're happy to help. Any more questions for me? I know there's delays, so I'm going to wait one more minute to try and see if there's any questions. Otherwise, tomorrow, we're going to do it on Zoom like we usually do. But my associate, my COO, Chris, has figured out how to live stream our Zoom messages to YouTube. At noon Eastern time tomorrow, we are going to have how to get your first cloud architect job webinar. And on this webinar, we're going to teach you a lot of things, kind of things that need to be on your resume, the kind of things that hiring managers care about. What is the actual job of a cloud architect so you know how to study it? What is the things you need to know? How do you interview properly and get hired, and much, much more. We will do that completely free. Chris probably has the link to that pinned to the top. I will ask Chris from my team to actually paste it one more time. So we'd love to see you in any of these free webinars. Everything we do is about building your career. Leo Paredes, thank you so much. I remember when you first came to me as a student, and I got to tell you, the things that I've seen you do and the speed that I've seen you do it is amazing. Jeannie, same thing with you. It's been absolutely wonderful having you as a student. I remember when we spoke when you were in Ethiopia for a while, and now back then you're in the US. It's been a great experience. Simon Cordova, no question from me, but if you could please continue to post ahead of time. Absolutely. So we try and post these available ahead of time. We don't want to do too many because otherwise you'll be seeing months and months worth of live streams ahead of time and it gets confusing to people. But we absolutely love it. So we will keep posting them. We are going to be doing a lot more. And thank you so much for your kind words. Derek, I am going to enjoy the evening with my wife. 25 years, yes, you know, I don't even know what life was like prior to my wife, but I don't think it was too good. Nick Love, thank you so much. I will definitely have a nice dinner when my wife comes back from her gymnastics lesson. I've got a whole day planned around taking special care of her because she puts up with me, and that says a lot. Not every husband has 10 servers floating around the house and routers and switches and firewalls in every room, things that sound like jet engines. So she puts up with a lot. So I am really lucky for that. So thank you so much. Any last questions? Otherwise, I will see you all very soon. Thank you, Reginald. Alonzo, always thank you so much. I appreciate that more than you know. Thank you for noticing our hard work, and thank you for all your help, Alonzo, with all the things that you do as well. So if there's no more questions, I will turn this all back over to you. Enjoy the rest of your day. If you found this content, please share it with someone else who found it useful. We love shares of our content. If you have the ability to send it to others, please do so. If you're not a YouTube subscriber, please subscribe and hit the bell so you'll be informed of these things. Sometimes we just go live immediately on the dime because we're inspired to do so, but other times we do this, so please join. Thank you, Leo Paredes. It is an honor and a privilege to be part of your educational process. Whether it's free or paid, we do not take that lightly. It is very serious, everything you do in your career. We work very hard to giving you the best free and paid content out there. And if you'd like us to do any more, if there's anything you're looking for, send an email to askcloudmike@gmail.com and I'll run it past my production team. John, thank you so much. It's been a pleasure since I met you very recently, but it's all been a wonderful experience. Thank you all, everyone. Take care and have a wonderful evening.